templates. You can select the required template and AutoCAD will launch using that template. You can also open files, sheet sets, and you can also look for templates online using all these tools. You'll see a list of recent documents which you have already used in this preview. Also, you'll see some notifications and suggestions for improving performance and other issues related to AutoCAD. You can connect with your Autodesk 360 cloud account from here. Right now you can see that I'm connected with my account, and here's my email ID. Now let's go and launch AutoCAD with the default template acad.dwt. Once you have launched, you'll see this preview. In this preview, here we have ribbon. Now this ribbon has got lots of tabs: home, insert, annotate, and there are many other such tabs. If you want to change the view of these ribbons, then click on this small arrow. Now this will minimize these panels to only icons. When you click on this again, this will minimize it further to its names, and once clicking it again, it will completely make it disappear. Click it again and this will come back to its original configuration. Now these are all the default panels. If you want to turn on any tab or panel, right click on this blank area. Go to show tabs, and now you can see that these are the tabs which are currently turned on. In this case, 3D tools and visualize tabs are turned off. If you want to turn them on, click on 3D tools. And here you can see that 3D tools tab will appear on the screen. Also, if you want to turn off any tab, go to show tabs and click on home, and there is no more a home tab. If you want to make it appear again, right click, show tabs, and check it again. You can also turn off these panels on or off. So right click here, go to show panels, and right now you can see that all the panels on home tab are visible. If you want to delete temporarily any panel, click on this checkbox, and now you can clearly see that the draw panel disappears. If you want to make it appear again, click on draw panel again. You can also move these panels from these tabs to your desired location. To move these panels, click on this blank area, hold your left key of mouse and move it. So clearly you can see that this panel now detaches itself from this panel, from this tab, and now it's present here. If you want to move it back to its original position, click on this small return panels button, and it will get back to its original location. Right now we are looking at AutoCAD in this tabbed view. If you want to bring menu bar, then click on this small arrow and click on show menu bar. This will make your menu bar appear on AutoCAD along with tabs and ribbons. If you want to make it disappear, click here and click on hide menu bar. The default workspace for AutoCAD is drafting and annotation workspace, which you can see here in workspace drop down menu. If you can't see this workspace, then click on this small arrow and turn on workspace from here. Once you have turned it on, it will appear here, and you can switch your workspace from drafting and annotation to anything else like 3D basics. So workspace are basically arrangements of tools and panels on this ribbon. So here you will find all the tools related to AutoCAD 3D, and a similar arrangement can be seen in 3D modeling, where you will find more such tools. So let's bring it back to drafting and annotations. You can also switch your workspace from this gear icon that you see on status toggle. So here on this lower right side of this AutoCAD window, you'll see this workspace switching. So click here, and now here also you can see this workspace switching box, and you can switch your workspace from here as well. On the top left of AutoCAD window, you'll see this application button. Click on this application button and you'll see all the shortcuts for commonly used application. This is similar to MS Word or any other application of Windows which you use, and here you'll see all the commonly used tools like save, new, open, save as, export, and other options. Using this application menu, if you want, you can open a new drawing, sheet sets, you can open an existing drawing or existing sheet set or other drawing objects. You can also look for commands using this search commands box. So for example, let's search for circle command and let's find out where it is positioned on the AutoCAD ribbon. So I will type circle, and now you can clearly see here that the circle command is on home tab and on draw panel on circle flyout. So let's go and look for it. So home tab, draw panel and circle flyout. Let's click here, home tab, draw panel, and here is the circle flyout. So you can see all the commands related to circle here along with its position and its location. So in this way you can look for any command using application menu search box. On the right of this application menu, you'll see some commonly used icons here on quick access toolbar. If you want to change number of icons from this quick access toolbar, click here, and now you can see that these are the icons which are currently active. If you want to activate any other icon, for example, let's activate plot preview, and here we have this plot preview. If you want to deactivate it, click on it again and this will disappear. You can also access online help of AutoCAD, which is a very versatile and complete tool in itself. To access online help, type here the command or anything which you need help with. So I will use rectangle and now press enter. So this will look into online help, and now here you have everything that is related to rectangle. So here you can find this rectangle, and there are other things also related with rectangle command. So this is a completely versatile tool which you can use to learn AutoCAD in itself. But for accessing this help, you need to be connected to internet. But if you're not connected to internet, you can also download offline help by clicking this icon and going to this icon here, download offline help. Before starting a drawing, the first thing that you need to do is specify units for your drawing. To specify units, type UN on command line and press enter. Drawing units window will pop up. Now in this window, here you will see at first length panel. Currently decimal unit is selected. You can change this decimal unit to architectural, engineering, fractional or scientific. You'll see a preview of these units here in the sample output panel. So when you change it to any other unit, for example to fractional, you'll see how and which kind of output you're going to receive. Next is precision. So first I'll stick myself to decimal units, and now let's change precision. Here we can see that there are a variety of precisions, and this is basically the output result which you'll get accurate to that many number of zeros. So if you select 2 decimal precision, it will give you an output accurate up to 2 decimal places. Now let's move on to angle. Currently decimal degrees angle is selected. You can change this angle value to degree, minute, second, to grades, to radians or to surveyor units. So I think you're familiar with decimal degrees. In case of degree, minute, second, it will change your sample output to somewhat like this. In case of grades, it is exactly like degrees with a small difference that 400 grades is equal to 360 degrees. So a circle is completely divided into 400 grades instead of 360 degrees. In case of radians, the angle will be measured in terms of pi, and 2 pi radians is equal to 360 degrees. So I'll change my angle to decimal degrees for this drawing. Now the default angle measurement is taken in counterclockwise direction, but if you want to make clockwise direction as positive, click on this radio button, and then clockwise direction will be taken as positive and counterclockwise as negative. But again, in this case I am going to keep it unchecked. Now this is the unit in which you want to draw, and when you click on this drop down menu, you'll see a variety of unit starting from mm and all the way to up to light years and even parsecs. So you can select any unit that you want from this unit drop down. So right now let's select millimeters, and now the drawing will be made in units of millimeters. This lighting unit panel has three options: international, American and generic. So you can select the lighting units from here, and these units will be helpful while creating a rendered view of your drawing. So I'll keep it at international. Once you have made all these changes, click on OK. Now this drawing has all the settings of unit which you have specified. While making a drawing, you'll need several times to move your drawing from one view to other. You'll also need to zoom in and out certain areas of a drawing. These can be done using pan and zoom tool of AutoCAD. You can type PAN on command line to access pan tool, or you can also type Z for zoom command and press enter, and this will show all the zoom tools on your command line. A shortcut for accessing pan tool is your middle mouse button or the middle mouse wheel. Press your middle mouse wheel and a hand icon will appear. So this will act as a pan tool. Now when you move your mouse, it will move this drawing completely. Release this button to get back to original condition. In order to zoom this drawing, move your cursor to the position which you want to zoom in, and now rotate your mouse wheel. When you rotate your mouse wheel in counterclockwise direction, this will zoom in your drawing. When you rotate it in clockwise direction, this will zoom out your drawing. The place where you put your cursor will be the center of zoom in and zoom out. There are also shortcut tools on this navigation bar for your help. So here we have many zoom tools. Let's start with zoom extents. Once you click on zoom extents, your drawing will fit completely in the view, no matter what the size of your drawing is. You can also select a window for making zoom. So go to zoom window and make a window, and this window will fit into your screen area. You can also select zoom real time, and once you select zoom real time, click on the screen, move your cursor upward to zoom in and move your cursor downward to zoom out. You can also zoom in certain parts of a drawing. To zoom certain part of a drawing, go to zoom object, select zoom object and select the object which you want to bring into your drawing and press enter. So now the drawing will completely occupy that object. You can also use zoom in and zoom out instead of rotating your mouse wheel. So when you click on zoom in, this will obviously zoom in your drawing, and you can repeatedly click on zoom in button to zoom it more. You can also click on zoom out and you can click it again to make your drawing smaller. One of the most fundamental geometries of AutoCAD is line. You can make a line by clicking on this line icon on Draw Panel of Home tab. You can also type L on command line or LINE short for line and press enter to initiate line command. Once your command starts, you can click anywhere on the screen to start this rubber bending line and click at the next point. And you can keep on clicking at successive intervals to make your line. To exit this line command, you can press enter. Now let's erase this. You can also make these lines using direct length entry. Select line, click anywhere on its screen, specify a direction. Right now I'm specifying this direction and enter the length. Right now I have entered a length of 5 units and press enter. So now this line is of length 5 units. Let's specify this as the direction and enter a length of 3 units and press enter. And here we have a line of length 3 units. So in this way you can make lines of specific lengths as well. You can also make line using specific coordinates. Right now I have made these 4 points at 4 specific coordinates. This one is 3, 1, this one 3, -1, this one -3, -1 and -3, 1. So now let's make a line that passes through all these points, or a rectangle that joins all these 4 points. So select line and enter a coordinate value of 3, 1 and press enter, and this will snap it to the first point. Now let's move on to the second point, and the coordinate value for second point is -3, 1 and press enter. Now to move on to this point, we need to enter coordinate values of this point. So this value is -3, -1 and press enter, and here it is, it snapped to that point. Now let's move on to this point. In order to move to this point, you need to enter its coordinate values, which is 3, -1 and press enter. To return back to the original point, you need to enter its coordinate, which was 3, 1 and press enter. So now here we have rectangle using coordinate values. You can press enter again to exit this command. In order to make a line at specific angles, you need to enter angle symbol on the command line. For example, if you want to make a line at an angle of 30 degrees with a length of 6 units, then select line command. Click on your drawing area to specify first point, or you can also pick a coordinate value. Right now I'm clicking on the drawing area to specify first point. Now in order to specify a specific angle, type angle on command line. You can find this angle symbol on the right side of M on your keyboard. Now type 30 on command line. This will tell Autocad to make an angle at 30 degrees and press enter. Now you'll see that this line gets logged at an angle of 30 degrees. Now enter the length of this line, which is 6 in this case, and press enter. And here we have a line of length 6 units at an angle of 30 degrees with respect to positive direction of x-axis. So this angle is measured from x-axis in an anti-clockwise direction. To make a circle, you can click on Home tab Draw panel on this circle icon. With AutoCAD, you can make 6 different kinds of circles indicated by this drop down menu. You can also use shortcut for circle, which is C or CIRCLE circle. You can use any of these shortcuts to start circle command. I will start circle command from this panel. So click on center radius circle. Now look at the command line. This command line is prompting you to specify center point of circle. To specify center point of circle, you can click anywhere on a screen, or you can specify it with coordinate values. Currently I am specifying it by clicking on screen. Let's click here. This makes the center. Now move your cursor and you'll see that the cursor your circle follows. Now enter the length of radius. I'm entering a length of 40 units for radius and press enter. And here we have a circle with 40 units as its radius. Now let's go to second circle, which is center and diameter. Now again specify the center point, and this time instead of prompting for radius, this will prompt you to specify diameter of a circle. So now let's enter 40 again and press enter. But this time 40 unit is total diameter, so the radius of circle is 20 units only, and the circle is comparatively shorter than the previous one. You can also go to this circle using center radius circle. So select center radius circle, click on a screen, and now here on command line you will see diameter. You can type D and press enter, or you can click here to go to diameter, and now enter the diameter. In this case I am entering a diameter of 60 units and press enter, and here we have a circle with diameter 60 units. Now let's erase these 3 circles. We have some other options for circle as well. The next option is 2-point circle. For making a 2-point circle, you need to specify 2 points. So here's the first point and here's the second point. Now click on this first point, and now click on the second point, and now this circle will be formed passing through these 2 points. Let's select the next one, which is 3-point circle. In case of 3-point circle, you need to specify 3 different points, and the circle will pass through those 3 points. So I've selected these two and the third point, and this circle will pass through all the 3 points. In this case, you need to specify 2 tangent values and 1 radius. So let's click here. Now click on this line, anywhere on this line, and click anywhere on this line. So these 2 lines will act as tangent for the circle. Now enter a radius. I'm entering a radius of 50 units and press enter. This makes a circle of 50 units radius, and it is tangent to these 2 lines. Let's select the last one, which is right tangent or tangent, tangent, tangent. In this case, a circle will be formed which is tangent to 3 different geometries. In this case, these 3 lines. Let's click on these 3 lines, and it will make a circle which passes through all these 3 points touching at single point, or a circle which is tangent to these 3 lines. To make a rectangle, go to Home tab and Draw panel and click on this rectangle tool. You can also select shortcut for this rectangle REC on command line. Let's click on this rectangle now. Once you click on this rectangle, you need to specify the first corner point for this rectangle. I am clicking at this point to make the first corner point. Now you have 3 different options in subcommand. Let's select dimensions. Now you need to specify length for this rectangle, as you can see in command line. Let's enter a length of 100 units for this rectangle and press enter. Now you need to specify width. For width, I will specify 40 units and press enter. So here we have this rectangle with length 100 and width 40 units, but still our rectangle is not complete. Now when you move your cursor to the left of this, you'll see this rectangle gets flipped towards left. When you move it down, it will move down, and when you move it towards right, it will go towards right. So now it can be placed in any of these 4 quadrants, and you need to specify the quadrant where you want to place it. Let's say that I want to place it in this quadrant, so place it here and then click, and this rectangle will be formed. We have another method of making this rectangle as well. So if we have area of this rectangle, then click at a point and select area from subcommand. Now specify area. Right now I'm specifying an area of 500 square units and press enter. Next, command line will prompt you to select either length or width along with area, and the other value it will calculate automatically. So let's select length, and let's specify a length of 50 units and press enter. So obviously when you made this rectangle with a length of 50 unit, the other length, which is equal to 10 unit, will automatically be created according to the area of this rectangle. If you want to create a rectangle aligned at certain angle, then click at a point and select rotation. Now you can see that your rectangle will rotate according to your cursor, and you can also specify a rotation angle. Let's select 30 for rotation angle. Now here we have this rotated rectangle. Now we have the same options for selecting dimensions of this rectangle. So let's select dimension, specify a length of 100 and a width of 40 unit. And here we have a rotated rectangle with length of 100 units and width of 40 units. You still have the option of selecting the quadrant in which you want to place. I'll click here to place it in the first quadrant. A polygon is any closed geometry with a minimum of 3 sides and a maximum of infinite number of sides. So theoretically, the smallest polygon is a triangle and the largest is a circle, which can be assumed to consist of infinite number of sides. But for AutoCAD we have a limitation, and that limitation extends from 3 minimum sides to maximum 1024 sides. So in AutoCAD you can draw a polygon with a maximum 1024 number of sides. For starting polygon command, go to Home tab and Draw panel and click on this small arrow which is right beside this rectangle tool and select polygon. You can also select command equivalent of polygon, which is POL, and press enter, and this will also start your polygon command. Now at first this command line will prompt you to enter number of sides. So let's make a pentagon. So I'll enter 5 and press enter. Now the command prompts you to select the center of polygon. So I am clicking at this screen in this drawing area that will be the center of my polygon. So here I have clicked. Now we have two options, inscribed in a circle and circumscribed about a circle. So if a polygon is inside a circle so that its every edge touches the circle, then it is said to be inside or inscribed in a circle. And for a circumscribed polygon, it lies completely outside a circle so that midpoint of every side of the polygon touches the circle. So this image makes it more clear to you. Now let's make an inscribed polygon for this case. So let's click on this inscribed, and now it's prompting you to select radius of circle, and this radius is the circle in which this polygon is inscribed. So I'm entering a radius of 50 units and press enter. So here we have polygon with radius of 50 units as its inscribed circle. Okay, now let's make a polygon which is circumscribed about a circle. So I'll select polygon. Let's select 5 as the number of sides. Here we have the center, and now let's select circumscribe. In this case, you can clearly see that this cursor is touching the midpoint of this edge. Now again enter 50, and here we have this polygon with inscribed circle of radius 50 units. Now if you know the length of sides of these polygons, then also you can make a polygon. So for that, let's go to polygon, select number of sides, which is 5 obviously in this case as well, and now instead of selecting the center of a polygon, click on this edge. Now this will prompt you to specify first point. So click at this drawing area, this will be the first point, and now select the second point. And in this case, you don't need to specify inscribed or circumscribed circle. So directly enter the value of its side or the length of its side and press enter. Right now I've entered 60 and press enter. Now each of these sides is of length 60 units. In Autocad, there are plenty of options by which you can make arc. The most basic one is using 3 points. You can find your arc command on draw panel of home tab, and here is the arc. When you click on this arrow, you'll find 11 different methods of making arc. Let's start with 3-point arc. As the name suggests, for making this arc you need to select 3 different points. So here I have this first point, click to make the first, then the second point, and then the third point. So this arc will pass through all the 3 points where I've clicked. Okay, let's go and erase this. Click on this arc again. Now next is start, center, end. Again, as the name suggests, you first need to click on the starting point, then center point, and then end point. Let's select this arc. Let's suppose that B is the starting point for arc. Now the center point will be A, and now you can directly see that here we have this arc. Right now the arc is created in anti-clockwise direction, and when you move to clockwise direction you won't see this arc. But if you want to create this arc in clockwise direction, then press Ctrl key and hold it there, and now if you move in clockwise direction the arc will be created. But the default direction is anti-clockwise, and it can be made like this. Now you can also click anywhere in this screen or select angle for making this arc. So I'm clicking here, and here we have this arc. Let's go to the next option, which is start, center, and angle. So here is the start point, which is point B again. A becomes the center point, and now we need to specify a particular angle, and this will be the included angle of arc. So let's say that we want to include it in an angle of 30 degrees. So type 30 on command line and press enter. Now this arc has been made, and if you connect this center point with this end point, and if you measure this included angle, then this should be equal to 30 degrees for this arc. Let's erase these two geometries. Now the next arc is start, center, and length. For this arc, again you need to specify a starting point, a center point, and now you need to specify length of this chord which connects these two endpoints. So let's say that I want to make an arc with a chord length of 100 units. So type 100 and press enter. Now if you make a line which connects this point to this point, then length of this line will be equal to 100 units. Let's get rid of these geometries. Now let's move on to the next one, which is start and an angle. So obviously in this case you need to click on the start point of arc, which is B in this case, then the end point, not the center of arc, and then you can see that this arc will be restricted in between these two endpoints. Now you need to enter the angle, the included angle of this arc. Let's say that I want to include an angle of 90 degrees, so type 90 and press enter. Now if you make a line which connects these two endpoints with the center, then these two lines are making an angle of 90 degrees, which is the included angle. So let's get rid of these geometries. Now the next one is start, end and direction. For making this arc, you need to select the starting point, then the end point, and now you can see that an arc is made with these two values, and this is following the tangent. Your cursor will follow the tangent. All you need to do is specify a direction in terms of angle. If you want to reverse direction of this arc, then press Ctrl and hold it, and now you can see that the arc will be made in the opposite direction. Now let's specify an angle for this. So I'm specifying an angle of 60 degrees and press enter. So now here we have an arc made in such a way so that if we draw a line that starts from this point and which is tangent at this point and extends, then the angle made by this line with the positive direction of x-axis will be equal to 60 degrees. Now let's select start, end and radius. For this you need to specify starting point of an arc, then end point of an arc, and then the radius of this arc. So obviously you need to select a radius which can be given to this arc. If you select a radius which is too small or too large for this circle, then this arc will not be created. So I'm selecting a radius of 50 units and press enter, and you can directly see that this arc was invalid. AutoCAD was not able to make this arc. Okay, so now I'll select this arc again and I'll click on the starting point and end point, and in this case I'm going to enter a radius value of 100 units and press enter, and here we have our arc with starting point, end point and a radius of 100 units. Okay, let's move on to the next one, which is center, start and end. For this you need to specify first the center point, then the starting point of arc, and then in anti-clockwise direction your arc will be made. All you need to do now is specify the end point for this arc, and in this case also if you want to change its direction to anti-clockwise, then you need to keep your control key pressed. So now here we have this arc. For center, start and angle, you need to first select the center, then the starting point, and now the included angle of this arc. So it's similar to the one we have already discussed. So type angle 30 and the angle of 30 degree will be created. So if you join this with this point, this end, then the included angle will be equal to 30 degrees. Let's look at center, start and length. In this case, first click on center, then starting point, and now you need to specify the chord length. So again, here in this case I am specifying a chord length of 120 units and press enter. Now if you connect these 2 points, then the length of this line will be equal to 120 units. Now let's look at this last one, which is continue. When you select continue, your arc will continue from the last drawn arc. Now you can see that this time this arc has been drawn. The next arc will continue from this point. So let's click on continue, and here our arc continues from the last drawn arc, and here we have this continuity will keep on going. In AutoCAD there are plenty of ways with which you can select your objects. Let's have a look at selection sets. When you click on the left of your drawing area and drag your cursor towards right, you'll see this solid window, which is called selection window or simply window. Now, if you click on the right side of this drawing area and move your cursor towards left, you'll see this dashed window, which is also called a crossing window. Now, the sole difference between these two windows is when an object within a selection window is completely enclosed, then only it will be selected. In this case, a circle and a polygon is completely inside this window, but it partially intersects this triangle. So only the circle and polygon will be selected when I click here. In case of a crossing window, when any object crosses this window, it will be selected. So the polygon is completely inside, but the circle and triangle both are partially inside and partially outside. But still, since they are touching this crossing window, they will be selected. We have other kinds of selection sets in Autocad as well. So let's first make this window. I have clicked on the left. I'm dragging it towards right. Now let's type CP for crossing polygon and press enter. Now you'll see that Autocad will make a polygon. CP was the short for crossing polygon, and now you can enclose objects more precisely. So in this case, this circle and this arc will be within our selection set. Press enter to make the selection. Now let's click here and again drag your cursor, and this time instead of typing CP, I will type WP and press enter. Now again this will make a window, but this time it will be a window polygon, and again you have a better control over the objects which you want to select. So in this case, this circle, triangle and a line will be selected. Press enter to make this selection. There is one more kind of selection set, that is with fence. So type F and press enter, and now any object which crosses this line or this fencing line will be selected. So in this case, we have these four objects: a circle, polygon, triangle and a line crossing this fence. Press enter, all of them are selected. So these are the different kinds of selection set. In order to move an object from one place to other in Autocad drawing, you can select move command, which you'll find on modify panel of home tab. So here we have this move command. Click on this command. Now select your object and press enter. Next, you need to specify base point, as you can see here on command line. Select the base point from where you want to pick that object, and now click on the destination point where you want to put that object, and the object will be moved. In order to make multiple copies of this object, select copy command. The shortcut for copy command is CO. Again, go to that object and click it. Now press enter. Again, you need to click on this base point, and now click at the destination point, and this command will continue, and you can keep on clicking on the destination points to make this object. You can also specify direction and enter a distance value for making a copy. For example, in this case, I am specifying this direction, and I'll enter a distance of 200 units and press enter. And here we have this circle at a distance of 200 units from this starting point. In order to make multiple copies, you can select array with copy command as well. For example, let's say we have a single line and we want to make multiple copies of this line. For that, select copy and select your object. Now press enter. Select your base point, and now you'll notice that on command line we have a sub command or a sub option, which is array. Click on this option and now select number of items in this array. Let's select 20 items because I want to have 20 such lines, and press enter. So here we have 20 lines. Now you can specify distance between these two lines either dynamically, or you can enter the distance value in your command line. You can also select fit from this command line, and all the lines will be placed within the limits of your cursor. So right now I'll specify distance with command line, I'll enter a distance of 300 and press enter. Now all the 20 lines will be adjusted in a distance of 300 units. In this way you can create multiple copies with array in AutoCAD. In order to rotate an object, you can select rotate command from modify panel. So here we have this rotate command on modify panel of home tab. Select rotate. Now select the object which you want to rotate. In this case I want to rotate this rectangle. Now press enter. As you can see that the command line now prompts you to select the base point, and the base point which you select will remain fixed, and that will also act as pivot point of rotation. So now let's select this corner point, this lower left point of this rectangle as the base point, and as soon as you select that point you will see that your rectangle starts to rotate along with your cursor, keeping that base point at its constant position. Now you can specify rotation angle using command line, or you can click anywhere on the screen to rotate it dynamically. So I will enter rotation angle from command line. Let's enter 30 and press enter. So here we have this rectangle rotated at an angle of 30 degree. In order to make a rotation along with a copy of this rectangle, you can select rotate, go to this rectangle, press enter, specify base point, and now from this command line click on copy. This will ensure that the original rectangle will be retained and the copy of that rectangle will be created at the angle which we provide right now. So let's enter an angle of 120 degree in this case and press enter. So here we have these two rectangles, and this rectangle is at 120 degrees. Now in this case we don't know the angle for this line. We have made this randomly. In order to rotate it at a particular known angle, you can select reference. So let's see how we can access reference from rotation. Select rotate, select this object and press enter. Now click on the base point. Again in this case this lower left point will be the base point, and now from command line select reference. Now you need to specify the reference line of our object. So here I'll click at this point as the origin and the destination. Now AutoCAD cursor will follow your line or the object. All you need to do now is enter the destination angle or the final angle. So let's enter 60 and press enter. So whatever the angle of your original line was, it's now changed to an inclined line of angle 60 degree, and in both the cases, in this case and in this case, the angle will be measured from positive direction of x-axis and in a anti-clockwise sense. Now in order to scale a drawing, you can select scale and it will increase or decrease your drawing size depending upon the scale that you provide. You can access scale command from modify panel, and here you will find this scale. Click on this command. Now select objects which you want to scale. Right now I want to select this object and press enter. Now you need to specify base point, and the base point will remain fixed. So let's select this lower left point as the base point. Now when you move your cursor, you will see that the size of this window changes along with the cursor, but we are not going to do it dynamically or with cursor. We can again enter a ratio here for changing this scale. If we enter a ratio value in between 0 to 1, it will decrease the size. If we enter a value greater than 1, then it will increase the size. For example, if we enter a value of 2, then it will make all the dimensions twice of its original value. If we make it 3, it will make it thrice. And if we enter a value of 0.5, it will decrease all the dimensions to half its value. So let's enter 2, and you might have noticed these dimensions. So keep an eye on these dimensions and now press enter. As soon as you'll do this, you'll see that all these dimensions now double in their value. So the overall scale of this drawing is changed to twice of what it was initially. You can also decrease its value. So let's select this scale again, select the object, press enter, and now specify the base point, which will be the lower left point in this case. But in this case, I want to make a copy of this object, and I want to retain this original object, and I want to make a smaller one along with the copy. So let's click on this copy and enter the value of your scale. So let's enter 0.25 as the scale or the factor, and now press enter. As soon as you'll do this, you'll see all the dimensions for this window is now reduced to 1/4 of its original value, and also the original rectangle or the original window will be retained. Now if you want to increase the size for this window in such a way that this bottom line reaches the size of this red line, and you obviously don't know the ratio for which you need to increase it, then you can use reference along with scale. So let's do this. Select scale and select your object. Now make sure that only the object which you want to change its scale value is selected, and press enter. Now specify base point, which will be the lower left corner in this case, and select reference from subcommands. Now click on the starting point and the end point of your original object. Now click on the destination point where you want to move it finally, and here we have it. So now this base has been increased to the size that we want, and all the rest of the objects will compensate for the size, and they will also increase in the same proportion. With an offset command, you can create a replica of original drawing object at a certain distance from it, keeping the geometrical consistency. Now in order to understand it, let's select this offset command from modify panel. So here we have this offset tool. Now look at this command line, which prompts you to specify distance of offset. So let's select 2 as the distance of offset and press enter. Now select the object which you want to offset, which is in this case this rectangle. So when I click on this rectangle, you'll see that it will create another rectangle either inside or outside this original rectangle, and if I click outside, then the rectangle will be created outside, and if I click inside, it will be created inside. So let's click inside. Now in order to exit this command, press enter again. If you want to use offset command, again select it. Now in this case, I'll enter another distance of 10 units and press enter. Now let's click on this arc and click inside. Now I'll click again and click inside, and you can clearly see that this maintains the geometrical consistency and thereby decreasing the radius of arc with each offset. You can also make a dynamic offset with this offset command. So select offset, and instead of entering any distance, select through from this subcommand option. Now click on this line or any other object from this geometry, and now you'll see that the offset follows your cursor, and here we have an offset which is completely parallel to the original line, and when you click here, a new offset will be created. Similarly, you can create an offset for this rectangle as well. When you click on this rectangle and move outside, a new offset will be created outside, and when you click inside, a new offset will obviously be created inside. Mirror command will create a mirror image of object about a mirroring axis, as the name suggests. For that, select mirror from modify panel. So here we have this mirror command. Select it. Now select the objects, as you can see here on command line. So select the objects from which you want to create the mirror and select enter. Now you need to specify first point of mirror line. So here this red line will act as our mirroring line. Let's click on this endpoint, and let's click on any other endpoint of this line, or you can click on the middle point, or you can click on any other point as well, but I'll click on this endpoint to make it more clear to you. So now we have selected 2 endpoints for this mirroring line. Now we have 2 options, either to erase the source object or to retain the source object. So by default, no is selected. So if you select no and press enter, then this object will also be retained and a copy will be created. So press enter, and now we have a mirrored object. Let's undo this and repeat this command again. So here we have this mirror. Let's select both the objects and press enter. Again, we need to select the mirroring line. So this will be the first point of mirroring line and the second point. And in this case, I'll select yes, I want to remove this object and I want to keep only the mirrored object. So select on yes, and the original object will be removed and only a symmetrical or a mirrored image will be created. You can use trim command to remove extra edges which are not required in a drawing. To start trim command, type TR on command line, which is its shortcut, and press enter. Alternatively, you can also select trim command from modify panel and home tab, and here you'll find this trim command. Now once you've selected trim command, your command line will prompt you to select objects which will make the line or the boundary for trimming. So let's select the boundary for trimming. In this case, we have multiple concentric circles and an array of lines. So let's select this middle circle as the boundary. Now we have selected the boundary, press enter. Now whatever object you select for trimming will be trimmed up to the boundary which we have selected. So let's go and click on any of these lines. When you move your cursor to the line, you'll see that its transparency or its darkness fades away, and also a cross symbol appears at the tool tip of the pick box. That indicates that this line will be trimmed off, and you can see the preview up to the point from which it will be trimmed. So when you click, the line will be trimmed up to the boundary which we have selected. So if we click inside, it will again be trimmed but up to the same boundary. Now you can repeat this process with any of these lines, and no matter where you click, it will be trimmed up to that object which we have selected. Now let's press enter to get rid of this trim command. Let's select trim again and press enter. This time, instead of selecting a boundary, we select all of the objects as boundary. To select all of the objects, press enter again. And now if you click on any object, it will be trimmed up to the next boundary. So now if I click on this line, it will be trimmed off, or it will be chipped off up to this next crossing line. So let's click here, and you can see that it has been trimmed up to the next line. This applies for this circle as well. So if I click at this portion of this circle, it will be chipped off up to the next crossing points. So, and I can repeat this process for as many lines as I want. One thing that you need to make sure of, that it will trim only these lines or circle or any drawing object only as long as there is a boundary. For example, in this case, we don't have any other boundary which intersects it. So if this is a last segment, it won't trim it any longer. Now in order to get rid of this trim command, press enter again. Now I will use another method of trimming using this example. In this example, we have this rectangle with these extra edges. In order to chip off all these edges at once, let's select trim command and press enter, and again press enter. Now here we have fence on this command line. Let's select fence in this case, and now make a fence that crosses all these lines, and this will ensure that everything that crosses this fence will be chipped off, or it will be trimmed. So now these lines are crossing the fence, and press enter, and you will see that it is completely clean. In order to use extend command, I'll use this geometry. It is completely opposite to the trim command which we have seen previously. You can select extend command from this drop down menu. So click on extend, and here again you need to select a boundary up to which your object will extend. You can see right now that here we have only one boundary. So let's make one more boundary using a new circle. So here I have one more boundary. Now let's go to extend command and select the boundary object. So here I have this boundary object, and press enter. Now after pressing enter, if you click on any line or any object, it will extend it up to the boundary which we have selected. In this case, it is the outer circle which we have selected. So when you click on this line segment, it will extend it up to that line or circle. Now, since this line segment is extending towards left and towards right as well, so if you click it close to the right side of this line, it will extend it towards that side. Now let's undo these changes and let's go to trim and let's go to extend again. So select extend, and this time I'll select all the object by pressing enter. Now if you click on any of these lines, it will extend up to the immediately next boundary. So if I click it here, it extended to this circle. If I click it again, it will extend it to the next circle. In this case also, now if I click it close to this circle or to this point, it will extend it here. And if I close to this end point of this line, it will extend to this side. So it depends on which side I click, that will decide where this line is going to extend. You can use trim command to remove extra edges which are not required in a drawing. To start trim command, type TR on command line, which is its shortcut, and press enter. Alternatively, you can also select trim command from modify panel and home tab, and here you will find this trim command. Now once you've selected trim command, your command line will prompt you to select objects which will make the line or the boundary for trimming. So let's select the boundary for trimming. In this case, we have multiple concentric circles and an array of lines. So let's select this middle circle as the boundary. Now we have selected the boundary, press enter. Now whatever object you select for trimming will be trimmed up to the boundary which we have selected. So let's go and click on any of these lines. When you move your cursor to the line, you'll see that its transparency or its darkness fades away, and also a cross symbol appears at the tool tip of the pick box. That indicates that this line will be trimmed off, and you can see the preview up to the point from which it will be trimmed. So when you click, the line will be trimmed up to the boundary which we have selected. So if we click inside, it will again be trimmed but up to the same boundary. Now you can repeat this process with any of these lines, and no matter where you click, it will be trimmed up to that object which we have selected. Now let's press enter to get rid of this trim command. Let's select trim again and press enter. This time, instead of selecting a boundary, we select all of the objects as boundary. To select all of the objects, press enter again. And now if you click on any object, it will be trimmed up to the next boundary. So now if I click on this line, it will be trimmed off, or it will be chipped off up to this next crossing line. So let's click here, and you can see that it has been trimmed up to the next line. This applies for this circle as well. So if I click at this portion of this circle, it will be chipped off up to the next crossing points. So, and I can repeat this process for as many lines as I want. One thing that you need to make sure of that it will trim only these lines or circle or any drawing object only as long as there is a boundary. For example, in this case, we don't have any other boundary which intersects it. So if this is a last segment, it won't trim it any longer. Now in order to get rid of this trim command, press enter again. Now I will use another method of trimming using this example. In this example, we have this rectangle with these extra edges. In order to chip off all these edges at once, let's select trim command and press enter, and again press enter. Now here we have fence on this command line. Let's select fence in this case, and now make a fence that crosses all these lines, and this will ensure that everything that crosses this fence will be chipped off, or it will be trimmed. So now these lines are crossing the fence, and press enter, and you will see that it is completely clean. In order to use extend command, I'll use this geometry. It is completely opposite to the trim command which we have seen previously. You can select extend command from this drop down menu. So click on extend, and here again you need to select a boundary up to which your object will extend. You can see right now that here we have only one boundary. So let's make one more boundary using a new circle. So here I have one more boundary. Now let's go to extend command and select the boundary object. So here I have this boundary object and press enter. Now after pressing enter, if you click on any line or any object, it will extend it up to the boundary which we have selected. In this case it is the outer circle which we have selected. So when you click on this line segment, it will extend it up to that line or circle. Now since this line segment is extending towards left and towards right as well, so if you click it close to the right side of this line, it will extend it towards that side. Now let's undo these changes and let's go to trim and let's go to extend again. So select extend, and this time I'll select all the object by pressing enter. Now if you click on any of these lines, it will extend up to the immediately next boundary. So if I click it here, it extended to this circle. If I click it again, it will extend it to the next circle. In this case also, now if I click it close to this circle or to this point, it will extend it here. And if I close to this end point of this line, it will extend to this side. So it depends on which side I click, that will decide where this line is going to extend. Fillet command of AutoCAD can be used to apply round edges on sharp corners. In this example, I'll use these 4 geometries which you see right now on screen, and I'll apply fillet command on all of them. You can find fillet command on modify panel, and here is the fillet tool. So when you click on this arrow, you'll see fillet tool here. Click on this fillet command and now look at the command line. So when you look at the command line, if it is expanded, you'll see current setting is trim mode and radius is 0.00. Since a fillet is going to apply a radius, so we need some radius. So let's add it. Click on this radius, or you can type its equivalent R and press enter on command line, but I'll select this radius from here. So click it and now enter the radius value. So let's enter a radius of 2 units and press enter. Now we have a radius of 2 units. So let's go and apply the fillet. For applying a fillet, you need to select first object or the first line and then click on the second line. So now the fillet is applied in between these 2 lines of the rectangle, and the radius of this fillet is 2 units. Let's undo this change and let's go to fillet command again. Now again we have trim mode and the radius is still 0. Let's go to radius again. Apply a radius of 1 unit. Now in this case, if you want to apply fillet to all the edges at once, for example this rectangle, select polyline, but make sure that the object is made up of polyline, which is in this case. Now click on any line and all the edges will have a radius of 1 unit. Now let's look at the second example. Click on fillet and now we have our setting, which is radius equals to 1. Let's go and apply fillet between these 2 lines. You can directly see that they are not intersecting and they are not even parallel. So when you click at these edges which are going to intersect if produced further, then a fillet will be applied, which is equal to the radius which you have selected. If the radius is small, then it will increase or decrease the length of these lines to compensate for it. So let's decrease the radius to 0.5 units and now let's apply it again. So now you can see that the length of these lines has been increased to compensate for the difference, and a new fillet has been applied. You can even apply fillet of radius 0 in between these 2 lines, and when you do so, these 2 lines will intersect at their apparent point of intersection. So let's go and select fillet command again, but in this case I'll select radius of 0 units and now click at these 2 boundaries and you have a fillet which is joining at the apparent point of intersection. Now let's look at the third scenario. In this scenario we have 2 completely intersecting lines. So let's select fillet again and now look at the trim mode. Here we have selected trim mode. Let's change this value. You can change this value from this trim subcommand. So click on this and now we have 2 options, trim or no trim. By default trim is selected. let's go and select no trim, and now select a radius, and the radius is 1 for now. And let's go apply fillet between these two edges. So select this edge, and we have a fillet, and these extra lines are retained. Let's go and repeat this process again with these two sharp edges here. Select fillet, go to radius and change it to something else, 2 in this case, and now apply it. Again we have a fillet, but the extra lines are not removed since we have selected no trim mode. And as long as you keep on this mode selected, it will always make a fillet along with extra lines. So let's go and change this mode. Select fillet, go to trim and select trim mode. Now go to radius, change the value of radius to 1, and now let's go and apply it. So I'm going to select this edge and this edge, and a fillet will be applied and the extra lines will be chipped off. Now what about these two parallel lines? These are completely parallel lines. You can even apply fillet between these two lines, but in this case, no matter what radius you select, a semicircular arc will be created at the ends. Let's select fillet, and let's now click at this corner point and now at this point, and you'll see that a semicircular arc has been created irrespective of the gap between these two parallel lines. And if you want to apply this semicircular arc in between these two parallel lines, then you need to click nearby to these two endpoints. So in this way, fillet command can be used to get different results. Now let's look at chamfer. I will use these geometries for chamfer. It's similar to fillet, but in this case we can apply an angular line. So when you click on this arrow which is close to this fillet, you'll see chamfer command hidden beneath it. So click on chamfer. Now again look at the settings. Here we also have trim mode, and now instead of radius we have distance 1 and distance 2, which is 0 in both the cases. So that means we need to change the distance first. So let's look at distance and change this distance to 1 unit. And now command line is prompting for second distance. So second chamfer distance, let's make it 3 and press enter. Now the command line is prompting to select the first line. So let's click on this first line and now click on second line. And here we have the second line. So what actually happened? We have a chamfer of length 1 and 3 units in such a way that if we increase length of this line and this line so that they intersect, then the length of this line is equal to 3 unit and length of this one is equal to 1 unit. And since I've clicked on this line first, hence this is the first distance, and when you click on this becomes the second distance. If I would have clicked firstly on this line, then this length would be 1 and this length would be 3. Let's undo all the changes now. Let's go to chamfer again and select distance, and this time I'll select a distance of 1 unit, again 1 unit. So now we have a uniform chamfer, and let's select polyline again. And as you know from the fillet command, a polyline command will apply chamfer on all the edges at once. So when you click on any of these edges, it will be applied to all the other edges. Similarly, with the case of chamfer, you can apply chamfer between these two apparently intersecting lines. So you can select chamfer, and now when you click on these two lines, a chamfer will be applied between these two lines. This chamfer can also be applied between these two intersecting lines. So when you select chamfer and apply the distance, it will be applied like this. You can also select a 0 distance chamfer to make these lines intersect at an apparent point of intersection. So let's go to distance and change it to 0 and 0 again. And now let's click on these two edges, and these two lines will intersect at their apparent point of intersection, just like in the case of fillet. Array command can be used in Autocad to create repeated pattern of objects. For example, in this case we have this geometry, and let's say that we want to create a pattern in such a way that we have 2 rows and 6 columns of this window. For that, I'll select a rectangular array first. So when you click on this small arrow button, you'll see we have three kinds of arrays: rectangular array, path array, and polar array. So let's start with rectangular array. Now when you select array command, you can see that this command line will prompt you to select objects. So right now we want to make an array out of this window, so select this window. So make a complete window to enclose it completely, and now press enter. So as soon as you do this, you'll see a temporary array appears on your screen with grips for making modifications. So right now you can make modifications using this grip. So when you click on this extreme arrow grip, it will replicate your array along its length. So when you drag it, you'll find that more windows will be created. In a similar way, you can use this grip to replicate this object into Y direction. The second arrow can be used to change gap between two corresponding lines or two corresponding columns. You can even reverse the direction of this array using these grips. So when you click on this extreme grip and bring it to the other side, it will reverse its direction. Similarly, you can reverse the direction along Y also using this grip. So let's now keep the direction as it was, and let's make changes using this ribbon. You'll also notice an array creation ribbon, which is a temporary ribbon that appears when you select an array command. So I'll make all the changes using this ribbon. So right now, as I said, that we need 6 columns, which we already have, so I'm not going to make any changes, but we can see that there is little gap on this side but a large gap here. So let's compensate for this, and I'll change value to 8 units. So type 8 and press tab. If you want, you can also make further changes to this. So let's change this distance to 8.5 units. Press tab to apply these changes, and you can see that the changes are reflected. You will directly see that if we change this value, this total gap between the initial and the end object will be added automatically. So, and when you change this value, let's change it to 40, you'll also observe that this value changes accordingly. So let's keep it at 8 and 40. Now let's move on to rows. Right now we have 4 rows which we don't need, and we only need 2 rows. So type 2 and press tab, and only 2 rows we have now, and the remaining 2 rows have been omitted. Now we have here a button for associative. So when you click on associative, you'll be able to edit your array even after you have made changes. So let's keep it checked and click on close array. Now we have our array here. When you now click on this array, you'll see that this ribbon appears again, and this is the result of checking associative button. So if you'll keep it unchecked, it will behave as if all these windows are separate objects. You can also return to non-associative behavior of an array by exploding it. So when you type X on command line after selecting your array and press enter, you'll see that all these objects are now separate from each other, and you can select them as a separate object. Here we have these two geometries. So let's start with this first one. Let's assume that we want to create multiple copies of this rectangle along this circle. For that, polar command can be used. So click on this array button and go to polar array. Now select this rectangle and press enter. Now you'll see on your command line that it prompts you to select the center point of array. So center point of array will be the center of this imaginary circle. You may or may not need this circle. This is only for your reference. So let's click at the center of this circle. As soon as you do this, you'll see a temporary array appears here, and 6 copies of this object will be created. We can again manipulate it using this temporary array creation ribbon. So let's move to number of items first. So right now we have 6 items. Let's change it to 24 and press tab key. As soon as you'll do this, you can see that the angle in between each 2 items is changed, and a total angle of 360 degree will be added. If you don't want to add this array to complete 360 degrees, you can change the angle to 270. Press tab, or you can even change angle to something else if you want. So now this complete object, 24 objects, will be filled within an angle of 270 degrees. So let's keep it at 360 for now, and let's press tab again. Now here we have rows. Right now only a single row is there. If you add more rows, like 3 rows in this case, you'll see more objects will be added. You can increase the gap between these objects to make it more clear, and let's add a gap of 25 and you will be able to observe it more clearly. So here we have these 3 rows, but obviously we want to keep it one so that we can clearly see this object. Again, in this case, if you add more levels will be added along z-axis or the z coordinate, which we cannot see right now because we are working in 2D geometry. Here again we have an associative option. So when you keep this associative option turned on, you can manipulate, you can change your array even after creating it. So let's keep it unchecked, because in the previous case of rectangular array we have kept it checked. Now we're not going to change the base point, but this is the base point for this object, so you can change it, you can manipulate it according to your needs. So right now this rotate items button is checked. When you uncheck it, you'll see that the alignment of this primary object remains as it is throughout the array. So that means this array object, they all are parallel to each other. But when you click on rotate items, you'll see that the objects start rotating, and when it returned back to the original state, it has already made a complete revolution of 360 degrees. So now we have seen and we have made some changes to this array. Let's click on close array now. And now when you click on any object, you'll see that this is a completely different unit, and you cannot return back to the array manipulation ribbon because we have selected a non-associative, or we have unchecked associative option from array ribbon. Now in this geometry, let's create a polar array. So let's select polar and select these 2 lines and press enter. Now we need to select center point of array, which is obviously center of this circle. So select it, and now we have this array. You can increase number of items to, let's say, 24, and here we have a complete array, and this represents a wheel or a bicycle wheel. Now let's close this array to complete this geometry. So this is how you can create a polar array. In AutoCAD, you can use direct distance entry method and also coordinate entry method to enter input points for your geometry. So if you want to use coordinate system, you can use Cartesian or polar coordinate system. In case of Cartesian coordinate system, here we have an origin, a positive x-axis and a negative x-axis. So here this right side of this origin indicates positive x-axis, indicated by this red line, and on the left you will see this negative of x-axis. Similarly, this green line indicates positive of z, and this green line on the bottom of this 0, 0, which is origin, you'll see as negative y-axis. We also have a z-axis which points outward from the screen, which is positive, and inward inside the screen, which is negative. Now let's make some drawings using coordinate system. So I'm selecting rectangle for this case, and look at the command line, which now prompts you to select the first corner point. Let's indicate first corner point as 0, 0, which is origin. So type 0, 0 on command line and press enter. So obviously when you do this, you'll see that the first point will be automatically snap to 0, 0 point. Now let's select the second point, and let's say that we want second point to be 10, 5. So here we have this 10, 5 indicated by this 10 from x-axis and 5 from this y-axis. So if you want to snap to this point, type 10, 5 and press enter, and automatically we see a rectangle which snaps to 0, 0 as its initial point and 10, 5 as its final point. Now let's say that we want again a rectangle, but this time we are not going to start it from origin, and we click randomly in the drawing area. Now let's say we want to enter 10, 5 again and press enter. So when you do this, you'll see that again this snaps to 10, 5, which is 10 according to x-axis and 5 according to y-axis. So no matter where you click, if you enter 10, 5 or any other coordinate, it will always snap to that coordinate value. So if we want to snap this second endpoint of this next rectangle, which starts from this point, let's say that we want to snap it to this point, which is 5 comma 7, then we only need to enter 5 comma 7 on command line and press enter, and it will snap it to that point. Now if you'll observe closely, then in this case length of this rectangle is 10 units and width of this rectangle is 5 units. But if you want to make a rectangle which does not start from origin and still you want to keep its length equal to 10 and width equal to 5, then you can use this at symbol. Now when you do this, AutoCAD will assume that the point which you have previously clicked is origin. So instead of treating this point as origin, AutoCAD will now treat this point which we have already clicked for this rectangle as the origin. Now enter 10 comma 5 and press enter. So now we have an identical rectangle, and this time the length of this rectangle is 10 units and width is 5 units, and obviously this point is not 10 comma 5 because we have already added an at symbol which indicates an incremental value, and now even if the length is 10 and width is 5, the coordinate is not 10 comma 5. You can verify this by checking its dimension. So when you check its dimension, you'll see it is equal to 10 units, and obviously the second one will be equal to 5 units. Let's say that we want to make a line in such a way that it starts from origin and is inclined at an angle of 30 degrees. So for that, select line command and enter 0 comma 0 as the first point. So now here we have this line with first point at 0 comma 0. Now in order to restrict this line to a certain angle, which is 30 degrees in this case, enter this angle symbol. This angle symbol can be seen on the right side of M key on your keyboard. So type this angle symbol and press 30. Now whatever succeeds this angle symbol will be treated as an angle, not as a distance or not as a coordinate. Now press enter. When you do this and move your cursor, you'll see that this line is locked to an angle of 30 degrees in both the direction. And now all you need to do is enter length of this line. So let's enter a length of 10 units, press enter. And now here we have a line with a length of 10 units and which is at an angle of 30 degrees from positive side of this x-axis. What if this line does not start from center? Again, if the same situation arises, let's say that this line starts from any other point. In this case also you can type angle 30, press enter. In this case also it will be locked at the angle of 30 degrees, and now you can enter the length. If you want to enter length and angle using a single command, then there is a syntax of command for that as well. So let's select line. Let's click anywhere in the drawing area and enter at. So when you do this, AutoCAD will assume this point as origin, and now enter length of this line, which is 10, and specify angle, which is 30, and press enter. And now enter again. So here we have a line with length of 10 units and angle 30 degrees with respect to positive direction of x-axis. So this is the method by which you can enter coordinate values in AutoCAD. On the bottom toolbar of AutoCAD, which is also called status toggle, you'll see these two icons, ortho mode and polar tracking. If these two icons are not visible, then click on this customization button and turn on ortho mode and polar tracking. Once it is turned on, go to any command. I'll select line for explaining use of ortho and polar tracking. So right now you can see that polar tracking has been turned on. Click in the drawing area and now move your cursor. When you move your cursor, you'll see that a green tracking vector appears when the line is completely horizontal. Let's rotate this line, and now you can again see the green tracking vector when the line is completely vertical. Let's rotate it towards another side, and again tracking vector after an interval of 90 degrees, and there is again a tracking vector after an interval of 90 degrees. So after every 90 degree we see a green tracking vector, and this line will be somewhat restricted to horizontal or vertical axis. So in this way it will facilitate making a drawing to those particular angles, and that can be done using this polar tracking. So when you click on this small arrow on the right of this polar tracking, you'll see that 90 is turned on, and obviously with 90, 180, 270 and 360 are also turned on. Let's go and change this value to 30 units now. Now when you move your cursor, you'll obviously see a green tracking vector 0-degree angle, but when you move it further, you'll see that there is one more tracking vector which is at 30 degrees, and then again at 60 degrees and 90 and 120. So we can clearly see that at an interval of every 30 degrees now a tracking vector will be there. So in this way you can restrict your cursor to certain angles, and it will help you in making drawings restricted to some angles without entering angle values. Although we have good amount of angles here, but if you're not satisfied with these many angles, you can apply your own angle as well from tracking settings. So click on this tracking settings and click on this additional angles checkbox, and now click on new. Let's say that we want to enter 18 degrees as our new angle, and now click OK. So when you click on this arrow, you'll see that 18 degrees has been added, and also the multiples of 18 are added. So let's go and turn this on. Let's select line, and now you'll see that after an interval of 18 degree the tracking vector appears, and at an interval of every 18 degrees the tracking vector will appear. You can turn it off, or you can change this value by clicking on the default value or any other value which you like. In case you want to delete this default value, go to tracking settings again, select the angle value and click on delete and click OK. Now let's click on this auto mode. When you do this, you'll see that this polar tracking is automatically turned off, so you can only keep either auto mode turned on or polar tracking. So let's delete these geometries, and now let's select this line again. Now if I try to make this line, you'll see that no matter where my cursor moves, it will always make a horizontal or a vertical line. So if auto mode is turned on, so irrespective of the position of your cursor, only a horizontal or vertical line can be created. If you try to snap this cursor to any other point, then only a line inclined to an angle will be created. So if I click on this point, then only a line which is inclined can be created. Otherwise I'll only be able to make a horizontal or vertical line. Let's press enter to exit this command. If you turn off this auto mode as well, and this polar tracking is already turned off, and if you select any command, let's say line, and you try to make a line, it will be very difficult for you to make a completely horizontal or a completely vertical line. So since this tracking vector is appearing, it is not because of this polar tracking, but rather it is because of object snap tracking. We'll learn about this in coming videos. So far we have made drawing using command line, but you can also make your drawing using dynamic input. On the status toggle here, you will see this DIN mode or dynamic input button. If you can't see this, then click on this customization and turn on dynamic input from this menu. Once this dynamic input is turned on, click on this icon and now select any command. Now when you select a command, you'll see that along with your cursor a tooltip appears, which is exactly equal to the options which you see on command line. So when you compare it with the command line, you'll see that the command line is also indicating you to enter the first point of this line. So you can clearly see that command line prompts you to specify first point, and here on the tooltip of this cursor you can see it's mentioned as a specify first point. And when you move your cursor, you'll see that x and y coordinates of this point or the current position changes. Let's click at this point. Now since we have clicked, you'll see that the values now change, and now you can see a distance. So this will be the distance of this line, which you can see in the first box. So in this case, let's enter the distance of 200 units. When you do so, this line will get locked to a distance of 200 units. So after entering this distance, press tab, and when you do this, you'll see that a lock icon appears with this distance box, and now the selection moves on to angle. Now you can enter angle about which you want to incline this line with respect to x-axis. So let's enter 30 degrees. You don't need to enter any symbol for degrees, and press enter. As soon as you do this, you'll see that we have a line with a length of 200 units and which is inclined to an angle of 30 degrees with respect to positive direction of x-axis. Now in this way you can continue making this line. Let's press enter again to exit this command. Now let's select circle for our next tool. So when you select circle, you'll see most of the commands which you can find here on command line. So specify center point for circle, it can be seen on command line as well on tooltip, but there is a small arrow icon which accompanies this specify center point for circle along with this tooltip. So this arrow icon is indicating the downward arrow of your keyboard. So when you press that arrow, you'll see that a menu appears which is exactly the same menu which you can see on your command line. So the sub commands or the sub options of this command line appears on your tooltip. Now when you press down button again, you'll see this small dot which moves, and now you can select your options from this menu as well. So let's select 2P, which is for 2-point circle, and press enter. Now your command changes to specify first endpoint of circle diameter. So here we have this first endpoint, and now we are entering the second endpoint, and instead of making a circle with radius or diameter value, we have a circle with 2 points. If you're not comfortable with dynamic input, you can simply turn it off by clicking on this dynamic input button. In order to select a point precisely using AutoCAD, you need to use Object Snap. So you'll see Object Snap on the status toggle here. So here we have this Object Snap icon, and if you can't find this Object Snap icon, then click on this customization and turn on 2D Object Snap. Once turned on, when you select any object, any drawing object, and move your cursor close to any other geometry which is already present in your drawing, AutoCAD will attract cursor towards that point. So in this case, you can see that a tooltip with endpoint indicates that simply means that right now, even if you click at a certain distance from that endpoint, AutoCAD will snap that line to exactly that endpoint, which we can see here. So now you can directly make a line, and you don't need to worry whether your line is exactly snapping to that point or not. Now let's go and turn this Object Snap off, and let's try to make a line that exactly fit at the intersection point of these two lines, and let's try to be as precise as possible, and now press enter. So in this case we have used Object Snap, but in this case Object Snap was not used. So let's zoom in. So when you zoom in, you'll find that this is exactly ending at the intersection of these two lines or at the end point of any of these lines which we have selected. But when you move your cursor to this one and when you zoom in further, you'll see that we are not exactly snapping it at the correct point. So this was the correct point, but it is not snapping. So in order to snap it to exact point, you need to keep Object Snap turned on. So let's zoom out and erase the geometry. So object snaps are of many types, and to find out which type of object snap we are tracking to or which we are snapping to, you can click on this small icon. When you do so, you'll see menu with plenty of snapping points, and there are some snapping points which are turned on, indicated by this tick mark, and there are some snapping points which are not turned on. So right now endpoint, midpoint and center is turned on. That simply means that you can now snap to the end point of a line, midpoint of a line, and to a center of a circle or an arc. Let's check these three values. So when you click on a line and when you move your cursor to the end point of this object, which is obviously a line, it should snap, but Object Snap should be turned on. So let's turn it on and move our cursor now. So now you can clearly say that it is a snapping to the end point of this line. So what about this line? When you move it close to this line, yes, it's snapping to this line. We've also seen that the midpoint snap is turned on. So here we have this line from this endpoint to this endpoint. Let's try to move a cursor close to the midpoint. So when you move close enough to the midpoint, a midpoint snap also appears. So that means you can snap it to the midpoint as well. Now let's look for some circular objects, and here we have a circular object, this circle. So when you move your cursor close enough to this circle, you'll see that a center snap appears. So even though my cursor is at the periphery or at the circumference of this circle, a center snap appears. And now if you click, your circle, your line directly snaps to the actual center, which is quite far from the circle. You can repeat the same process for other small circular objects also. For example, in this case we have a circle. Now if you bring your cursor close to the center, you'll see this center snap appears. So when you click, it will snap exactly to the center point of that circle. In AutoCAD 2016, we have a new feature with Object Snap, and that is Geometrical Center. So when you click on this button, which is adjacent to this Object Snap, then you'll see this Geometrical Center option. Turn it on, and now when you try to make an object and drag it towards the center, which is the Geometrical Center obviously for any of these objects, then it will snap to that point as well. So here you can see the geometrical center for this rectangle, and if you move it close enough to this polygon, which is a hexagon, you'll see its geometrical center as well. So with AutoCAD 2016, you can snap to the geometrical center of these geometries as well. Now let's look at some of the other points which are indicated in this object snap. Now the next point is node, which is point. So in order to snap to a point object, you need to turn node on. So let's type POINT for point and press enter, and let's make some points. So here we have a point. You might see point in a different way in your AutoCAD geometry. So you can type P type on your command line, press enter, and change the point type from this. Right now point type of this is selected in my case, so in your case it must be this default. You can change it to any other point type. Let's say that we have selected this one. Now if you move your cursor close enough to that point, it should snap to that point. If on object snap this node is turned on, otherwise it won't snap to that point. Let's turn quadrant on and now move our cursor close enough. So when you move your cursor close enough, you will see that it's snapping to the quadrant, another quadrant, third quadrant, and fourth quadrant. So in this way you can snap to the quadrants using that quadrant as well. There are some intersection points also in this drawing. So in order to snap to those intersection points, you need to make sure that intersection is turned on. For example, in this case we have these two lines intersecting at this point. So let's go to this snap menu and turn off midpoint, and let's turn on intersection, which is already turned on. Now let's select line and move your cursor close enough to this, and when you do so, you'll see that intersection is indicated, and now it's exactly snapping to the intersection point of these two lines. It can be a line or a circle, or the intersection of line and circle, or any other two geometries. There are other options as well in this object snap that I encourage you to explore on your own. Object snap tracking can be used to create geometries from points which are not visible on your screen. For example, in this drawing we have these two circles, and the center for these two circles are not indicated in this blank drawing, so we don't have a reference point for creating center point for this circle. In these cases you can use object snap tracking. Object snap tracking can be seen on status toggle here. So here's the object snap tracking right beside object snap. So click this to turn it on. If you don't find this icon, click on this customization and check this object snap tracking mark. Once you have this icon turned on, go to circle command, and now let's try to make this first circle. I'll first go to the midpoint of this line, but don't click. So now bring your cursor here and then drag it directly downwards. So when you drag it downwards, a green tracking vector will appear. Now don't click anywhere and move your cursor directly towards left, and when you'll move to left, you'll see again a midpoint snap, and now track it towards right. So when both the tracking vectors meet, an intersection point will be created, and now when you click here, a circle will be drawn exactly at the intersection point. Now enter the radius, which is 20 units, and press enter. So here we have the circle. Similarly, to make this a smaller circle, we can track these 2 points. So this circle is exactly made at the intersection of these 2 points. So let's go to circle again and go to this point, but don't click. Now track your cursor towards right. Now go to this point and again don't click and track it upwards. So as soon as you reach the intersection point, an intersection point for these tracking vectors will be indicated. Click at this point, enter the radius, and here we have the final geometry. You can use hatch command from draw panel of home tab. So here is the hatch tool. Click on this hatch button. You'll see that a temporary hatch creation ribbon will be created. Now using this ribbon will create hatch patterns inside the closed geometries. First you need to ensure that pick point is selected. Right now a pick point is selected because my cursor is point selection cursor. If it is not point selection cursor, then click on this pick points button and your cursor will look like these 2 perpendicular lines. Now move your cursor to an area where you want to create your hatch. So right now let's say that I want to create hatch in this area. So when you move your cursor to this area, you'll see a preview of the hatch. You may or may not need this kind of hatch, but let's just click it. So when you click here, you'll see that this hatch pattern automatically detects the island and it will fill complete island excluding this extra geometry. Let's go to this pattern panel. Right now angle pattern is selected. Let's change it to ANSI 3.1 and the pattern is now changed to ANSI 3.1. It's extremely closed. In order to change this close spacing of these lines, you need to go to scale. So go to properties panel and here you will find this hatch pattern scale. Change this scale value to 5 and press tab. You'll see that now hatch patterns are further apart. You can increase this scale value to make it more widely spaced. Now let's move back to patterns. When you click on this small arrow icon, this pattern panel will expand and now you can see a whole lot of patterns which are in AutoCAD. So you can use any kind of pattern for your drawing. Let's keep our selection to ANSI 3.1 for now. Now move on to this pattern panel. Here you'll see 3 options: pattern, gradient and solid. We'll look into gradient in a moment. If you change it to solid, you'll be able to fill a solid color in the area. So right now you can see that this complete island has been filled with a single color. In order to change the color of this pattern, click on this by layer drop down and now here you'll see all the colors. So this is the hatch color drop down menu. From here you can pick your colors. If you're not satisfied with these many colors, you can go to more colors and select from index color, true color or color books. Let's keep our selection to this drop down only, and now here I have selected a color for this solid hatch pattern. You'll also observe that when you select solid from this drop down menu, solid will be selected in the pattern as well. So you may select it from here also instead of this drop down menu. Now let's go and close this hatch pattern. So click on this close hatch creation and your hatch will be completely created with a solid pattern. Now let's move on and create some more patterns on this drawing. So go to hatch again and now I'll create a hatch pattern in this island. So click in this island and now you'll see that the internal geometries are excluded as expected, and change this hatch pattern to NC31. And when you change it, you'll see that the color of hatch remains the original color which we have previously used. So in order to change the color, click on this drop down menu and change it to something else. Let's say green this time. You'll now see a different background color drop down as well. So when you go to this background color drop down, you can change the background color for your hatch pattern. So let's say I want to change this background color to yellow, and here's the changed background color. So let's keep it at none if you don't want any background color. Now we have made the pattern on this island. Let's go and close hatch creation again. There is one more method of adding hatch to your drawing. So far we have used island detection method. Let's go and select the object method, in which we won't select pick points, rather we'll select the object. So select hatch, and now instead of selecting pick points, click on this select boundary objects. Now you'll see that your cursor is converted to a pick box, and in this case you can select a polyline or a closed geometry to make your selection. For example, in this case, if I select this polyline, complete hatch pattern will be created inside, and any boundary which is present inside this geometry will be ignored completely. Let's say that I want to create a hatch pattern angle with a scale of 1 unit in that area. So here is my pattern ignoring this boundary. If you'll create this hatch pattern inside this boundary, then also it will ignore all these internal geometries. So let's delete the hatch pattern which we have previously created and click on hatch, select object, and now select this rectangle, and you'll see that all the geometries which are present inside is completely ignored. Dimensioning is very crucial feature of AutoCAD drawing. For dimensioning, you can go to annotation panel of home tab, or you can go to annotate tab and dimensions panel. I'll select dimensions panel, select linear from this panel, and now select the point from where you want to start your dimensioning. Right now I'm not able to select this point. For this you need to turn on O snap. Also you need to make sure that these points, end point, midpoint, center and intersections are turned on. Let's select the first point and then the second point. Place your cursor at a certain distance from your original drawing and your dimension will be created. Right now this dimension is created with a length of 56 unit. Let's select linear again, select this point and then this point, and again the next dimension will be created. If you want to create a aligned dimension, then you should select the second option, which is aligned. When I select aligned dimension, then it will create a dimension which is parallel to the object which we have selected. So in this case, here is the aligned dimension. But if you select linear for making aligned dimension, it will create either a horizontal or a vertical dimension depending upon the position where you place your dimension. So let's place it here. Let's move on to the next command, which is arc length. Here we have this arc. So when you click on this arc and expand it, it will create a dimension which is equal to length of this arc, and it is also indicated by this arc length symbol. Please make a note that this is arc length, not diameter or radius value. You can also select arc length and specify length of arc for this smaller arc. Let's move on to the next option, which is radius. For specifying radius, click on the arc, fillet or circle and drag your cursor. So here's the radius, which you can clearly see that it is 24 units and length of arc is 54.06 units. Select radius again, click on this circle and let's make it here. So here's the radius, which is 35 units. Let's click on this arrow and select diameter. Now this will create a diameter. Right now you can clearly see that the radius is 35 units. Click on the same circle again and you'll see the diameter is now indicated as 70 units along with phi symbol, which indicates the diameter of the drawing. Let's create continue and baseline dimensions. For continue dimensions, first create a dimension. Now this dimension will act as standard for creating our dimension. Now click on this continue button. As soon as you click on this button, you'll see that your next dimension starts from the point where you left initially, and now click at the next point, which is right now the center of this circle. Now click at the next point and again next point. So in this way your dimension will keep on continuing from the initial point in a single chain. Let's now move on to baseline. So when you select baseline dimension, it will prompt you to specify the dimension as base dimension. Let's select this one. So now once we have selected this dimension, it will again start dimensioning from the last point of this dimension, but in this case it will create the dimension with a slight difference. Let's select the center point now and then this point, and this point. Now in this scenario, all the dimensions are measured from the initial point which we have selected. So this becomes the base point and all dimensions are measured accordingly. Dimension style decides the properties of a dimension like text style, arrow, color of dimension, text, leader line, and other properties related to dimension. Let's move on to Annotate tab and click on this dimension style drop down. You'll see that we currently have three dimension styles: annotative, ISO 2.5 and standard. Now in order to make our own custom dimension style, click on this manage dimension style. You can also select dim style from command line for this dimension style manager. So type dim style and press enter. So this will also bring dimension style manager window. In order to make a new dimension style, click on new and give it a name. Now click on continue. So this will take you to my standard dim style. Now we have multiple tabs here with which you can create your dimension style and make multiple changes in your dimension. So let's start with this lines tab. So this is dedicated to all the lines which are present in dimension line. So currently this panel will change all the properties related with dimension line. For example, color. So you can change color for your dimension line using this. You can also change line type from this. You can load your line type and change it to some other line type. There are some other options like line weight, but these settings will only apply to this dimension line, and the preview you can see here. Now for extension lines, which are these lines, you can modify options from this panel. So here also we have a drop down for color, extension type line 1, and for line 2 drawing line type. We also have a line weight option. Now when you suppress any extension line, that extension line will not be visible, but this you can also suppress from property panel, so you may ignore this part. Now here is extension beyond dim line, which is this small extension way beyond this dimension line. So when you select it as 0, you will observe that there is no extension beyond this dimension line, but let's restore it to 1.25. So here is the extension. Also here we have an option for offset from origin, which is this small gap which this maintains when it dimensions. So the dimension now starts at an offset distance of 0.625 from the point which we select. If you select 0, dimension will start right at the point which you click. So let's again keep it to 0.625, which is the default value. Let's move on to symbols and arrows. So here we have some arrows. So now we have close fill as the default arrow. Let's change it to some other arrow type. In this case, I'm selecting this right angle arrow. Now the arrow type has been changed, and you'll also observe that the second arrow type is changed. But if you change the second arrow style, it will not change the first arrow style. So in order to change both, just select the first arrow style and both will be changed. Let's click and change it to right angle arrow style. For leader line, you can change arrow styles from here, but since we don't have any leader line in this preview panel, we won't be able to show it now. Here is the arrow size, which can be modified from here. So right now the arrow size is set to 2.5. You can change this arrow size from here. When you move on to this text tab, you'll also see that we have a text height which is generally equal to the size of our arrow. So here also you can change the size of text. For example, let's change it to 5 units and press tab. Now the size of this text changes to double its original size. Let's keep it at 2.5. In this text tab, we have all the settings related to text, like text style. Let's change this text style. So right now we have a standard and annotative. We have not yet seen annotative, so I'll leave it for now, but we'll look at annotative property later on. If you want to change font style of your text, click on this small box. It will take you to text style window, and from here you can change your font style. So let's change it to Comic Sans, and here it is. So now this looks so unique. Click on apply and close it. So Comic Sans style is now applied to this. If you want to change text color, you can select this box and change it. So let's change it to red. In order to fill the background color of your text, you can select any other color. So right now a background color is applied. If you want to draw a frame around that background, then click on this draw frame and a frame will be drawn, but I'll keep it at none, and I'll also uncheck this draw frame. So here we have this dimension. Now the placement of text will be decided by this panel. Currently we have text above dimension line. If you select it is centered, all the dimension text will be centered, and similarly other options will behave. So let's keep it at above. Right now you'll also observe that the dimension text is aligned along with the dimension line. So here it is vertical, horizontal, and now aligned with the dimension line. But when you click on horizontal alignment, all the dimensions will be horizontal irrespective of the orientation of dimension line. So let's keep it at horizontal. Now move on to fit tab. On this fit tab we don't have much to look at, but if you want to change the complete dimension style to annotative, you can check this annotative box and the complete dimension style will change to annotative. Here is an overall scale which we can change. So right now whatever the size of dimension is, if you change it to something else, let's say 10, then the complete dimension will increase to 10 times of its original values, and this includes the size of arrow, text, and other objects. For now I'll keep it at 2.5 and we will look at this option in a moment. Now let's move on to primary units, and here we have a very important setting to make. In this primary unit we have decimal as our precision format. Now if you change it to architectural, you'll see feet and inches type of format, and also we have some other fractional and engineering unit. So you can select your format of dimensioning from this drop down. So let's keep it at decimal now. So here we have a precision. So right now precision of 2 decimal points is selected, so the dimension will be reported accurate up to the 2 decimal points. So let's click on 3, and now after decimal point you'll see 3 places of this dimension. For a decimal separator, a period is selected. You can also select comma and space for this decimal separator. So now we have made enough changes to this drawing. Now let's click on OK, and let's see how our dimension style looks. Now click on set current and close. Now you can clearly see that in this drop down menu we have my standard dimension style selected as the current dimension. Now let's move on to this linear dimension and try to make a dimension here. So when I make a dimension, this will inherit properties which we have defined right now. Now let's move on to linear again and define the properties here. So here we have this dimension style. Now let's move on to this dim style again and click on modify and go to fit tab. So if you find that your dimension is too large or too small, then you can select this fit tab and change this overall scale to something else. Let's change it to 5, and now the text and arrow and all the dimension parameters will be changed to twice its original value. Let's close it and you'll see the difference. So right now all the parameters are now doubled of its original value. If you want to move back to any other dimension style, then click on this drop down menu again and change it to any other dimension style. Let's say ISO 25, and now when you make a new dimension, it will create your dimension according to ISO 25 standard, and the standard which we have created will no longer be used. Multileaders are an important part of Autocad dimensioning. They can be used at places where you want to specify certain notes or information about the part of a drawing. Let's use multileader to specify parts of dimension and drawing object on the simple Autocad drawing. You can access multileader from Annotate tab and Multileaders or Leader panel. So here's the Leader panel. Now from this leader, you'll see here Multileader button or icon, which can be used to initiate multileader command. So let's click on this multileader. A normal multileader will start with a leader line and a text. So let's say that we want to place a multileader on this corner. So click on this corner, drag your multileader, click at the second point, and now enter the text information. Let's say that we want to enter corner as the text information. Now to exit this, click on close text editor. And here we have this multileader. Now this is not all about multi-leaders. We can create different kind of multi-leader and we can use them in our drawing as well. Now let's say we want to use a different kind of multi-leader. For that, go to view and click on tool palettes. Now this will bring a tool palette with multi-leaders. You may find that in your case tool palette is little different, like these kind of tool palettes. So if you find these kind of tool palette, then go to this bottom, click on this and then click on leaders. So this will bring multi-leader or leader tool palette in front of all the palettes. We have selected this one, leader with text, this one, leader with text. Now if you select leader with no text, it will clearly add a leader without any text. Let's check other functions here of multi-leader. So let's select this one, leader with circle. Now click at a point and let's click at the second point and now enter a tag number. So let's say that we want to enter tag 01, which indicates first corner of this rectangle, and click OK. So now in this case, this multi-leader will be added inside a circle. Similarly, if you want to enter a leader inside a box, you can use this box, hexagon, triangle, and even a slot. So let's select slot, click at this point and then second point and enter the tag number, which is 02, and OK. So here we have a multi-leader inside a slot. You can also use a detail bubble for your multi-leader. So let's select detail bubble, click at this fourth point, click here and now enter 04 and then in sheet number enter rec, REC, which is for rectangle, short for rectangle. And here we have a different kind of multi-leader. You can add multi-leaders and align them in a single line. For example, let's add multi-leader in this drawing again. So I've selected this common multi-leader, the normal one, and let's say that we want to specify components of this dimension. So now this line is called an extension line. So let's say we're going to enter a multi-leader here and let's enter extension line and click outside to create this multi-leader. So here we have a multi-leader which is indicating that this one is extension line. Let's select another multi-leader, click on this arrow and now we'll specify it as arrow. So this multi-leader is an arrow. Let's select multi-leader again and this time I'll click at this point and now this multi-leader will indicate that this is the center mark. So center mark and click outside to exit this. So we have indicated three different kind of multi-leaders. Let's add one more multi-leader and in this case I'll enter this as our drawing, or let's say as a rectangle. So rectangle. Okay, so here we have this rectangle. Now you can see that these all multi-leaders are not properly arranged. So in order to arrange them properly, all you need to do is select this align multi-leader, select the multi-leaders which you want to align, now press enter and then select the multi-leader which you want to keep as a base point for aligning, or the multi-leader which you want to keep as a standard. So let's select this one. So once you do this, all the multi-leaders will be aligned with respect to that one, and now make a straight line either downwards or upwards. And here we have it. All the multi-leaders are now aligned in a single straight line. If you want to add multiple multi-leaders, that also you can do. For adding multiple multi-leaders, select on add leader and let's click on the multi-leader and you'll see that a new leader line will be added to that multi-leader. So now let's enter a point here. So let's click at this point. And let's click at this point, although this is a random point in space with no proper meaning, but still you can see that we have center mark indicated for these three different multi-leaders. In order to remove the multi-leader, select on remove and click on this one and this one which you want to remove. So I want to remove this and press enter. So we have removed the multi-leaders. In Autocad, you can enter text just like any other text editor program like Notepad or Microsoft Word. But every kind of text has some properties like text font, its text height, oblique angle, etc. So these properties are defined by text style. By default, you'll find that AutoCAD has two text style, standard and annotative. You can look at these text style when you expand this annotation panel and click on this drop down menu for text style. Here you will see annotative and standard as the text style which are predefined. You can create your own text style by clicking on this manage text styles. You can also use its command equivalent, which is ST. So let's use the command equivalent. Type ST on command line and press enter. So this will bring text styles window. Now we can create our own text style here. You can clearly see that we have annotative and standard as text styles. Now click on new and create a new style. Let's name it my style and click on OK. So here you will see my style text style has been added. Now we can make changes. Let's go to font first. So the default font txt.shx is selected. Let's change it to Arial. So here we have Arial. You can see the preview of changes in this box. Now the font style is regular. Let's change it to bold. If you want to make this text annotative, you can click this checkbox, else you can leave it. We are not going to make it annotative for now, so let's leave it. In text height, you can change it to any other value if annotative is not checked, or you can even leave it at 0 and change this value later on using text editor tab. Now there are some effects which you can add, like upside down and backwards. You can also make these texts vertical, but right now for Arial font you won't see this vertical option activated. So this option for vertical is available only for certain kind of fonts, especially .shx fonts. So let's leave it for now. And here we have this width factor, so which is currently set to 1. So when you change this width factor to 2 units, the text width will become twice of its original value. Let's leave it at 1 for now. And this oblique angle will create a italics text. So let's say that we want to create a text at an angle of 30 degrees. So here's the oblique angle, which is 30 degrees with respect to the vertical axis. So again here we don't want to make it oblique, so let's keep it at 0. So here we have made some changes to this text style. Now if you want to keep this text style, click on apply and now close it. Now when you move to this expanded annotation panel, click on this drop down, you'll see that my style text style has been added, and in our next video we will use this my style in our drawing. In previous video we have created a text style with the name of my style, and that you can see in expanded annotation panel and in this text style drop down. So here's the style. Now we'll use this style to create text in our drawing. So first let's start with single line text. The shortcut for single line text is text, T-E-X-T. So type text and press enter. So this will start a single line text. You can also start single line text by clicking this button on annotation panel and clicking on this single line option. This will also start single line text. As you can see in command line, we need to specify a start point for our text. So let's specify a start point by clicking in the drawing area. So this becomes our start point. Now we need to specify a rotation angle for text. So if you want to make your text align to certain angle, you can specify the angle now. Let's keep it at 0 for now. So type 0, or you can even omit typing 0 because the default value is 0, and press enter. So this will make a completely horizontal text. Now let's enter the text which you want to enter, and I'll enter AutoCAD 2016 as the text. So now here we have this text. If you want to exit it now, press enter twice. So now here we have this text. If you want to make changes to this text, you can double click on this text and now you can make changes. Like let's enter software to this and now double click again to exit this. Let's go and explore other options which are related with single line text. So this time I'll start single line text by clicking on this button. So here is the single line text. Now here we have these two options, justify and style. So currently our style is my style, which is the style which we have created in previous video. Let's change this style to standard. So click on style and type the name of style. So standard. So that's the standard style and press enter. Now the style has been changed to standard. Now click anywhere in the drawing area and enter a text height. So currently you can see that the standard text height is 2.5. So we'll keep it at 2.5. We are not going to change it. So press enter. Now it will prompt you to specify a rotation angle. So let's change this rotation angle to 30 degrees. So type 30 and press enter. So now here we have our single line text. Enter the text Autocad 2016. I think I missed one, so enter 2016 and press enter twice. So here we have our text. So you can clearly see that in this case the text has been created according to standard style which was already present, and the standard is now selected. The font style and the height of text including the angle has been selected according to the style which is defined in standard. If you change it to my style or annotative, then it will take the properties which were defined in these respective text styles. A single line piece of text can be entered in a place where we only want to specify a short piece of information, but a multi-line text can be added in places where we want to add long lines and paragraphs of text. For example, in writing copyright information, we can use multi-line text. You can start multi-line text by clicking this arrow button on annotation panel and selecting multi-line text. The shortcut for multi-line text is M text. Type M text on command line and press enter. So this will start multi-line text, and it will obviously start it with the default text style which is selected. So right now you can see that the default text style is standard, which is selected right now, and the text height for standard is 2.5 and it is not annotative. So let's start with this text style. So we need to specify the first corner for our text, and now we just need to specify another corner. So it hardly matters where you click. So click anywhere and this will start your text, multi-line text to be specific. And also you'll notice that a new text editor tab will appear. So this is a temporary tab which will appear only till you're using this multi-line text command. Now let's enter the text which we want to enter here. So let's enter Autocad 2016. So here we have it. Now you can make multiple changes in this piece of text using this text editor, and this text editor is very much similar to the text editor which you find in MS Word. So let's move on to the first option here. So the first option is obviously for style, which is right now is standard. If you want to change it to some other style, click here and change it to any other style. Now you can see height of text here. If you want to change height of text, you can override it even if a style is defined. So let's say that we want to enter a height of 2 units. So here we have it for 2 units. So let's enter 2 and press tab. So here we have a text of height 2 units. If you want to make it annotative, you can click here to make it annotative as well. So here we have bold, italics, underline, overline, then superscript, subscript, uppercase, lowercase, and strike through. You can also create stacked text. For example, let's say that after 2016 we want to write A oblique B. So type A, then oblique B. Select the text and click on this stacked. So here we have this A oblique B in the stacked form. Now you can override the style for this text as well. So let's select this AutoCAD and click on this style and change it to something else. So let's say that we want to change it to this text style, and here we have it, a different text style. To change the color, we can select this color box, and here we have the color for this text. You can also change justification for this text, although it might not be visible for you in this small text editor box. So let's expand it, and now let's change this justification. Right now top left is selected. If you change to top center, so here's the effect and here's the top right. Similarly, middle left, middle center, middle right, and all the other options will have their respective effects. If you have multiple lines of text here, you can also apply bullets and numbering. For example, let's remove this line, make a copy of this. Let's click on this don't show. We don't want it to appear again and again. Press enter and paste it for multiple times. So here we have this text multiple times. Now let's say that we want to make it bulleted text. So select it, select bullets and numbering, and make it numbered. So here we have it. If you want to apply letters, you can apply either lowercase or uppercase. So let's apply lowercase letters. So here we have this lowercase letters. You can also apply direct bullets without any numbers or letters. To turn it off, click on off and there will be no bulleting and numbering. You can also change line spacing and many other things. So let's remove these extra lines. Here we have one more option, which is symbol. So obviously you don't have all the symbols on your keyboard. In case you want to enter a symbol which is not present on your keyboard, you can take help of the symbol. These symbols are Windows symbol and these are not present in AutoCAD software. So AutoCAD mostly uses symbols which are present in the Windows library. So let's say that we want to use $sign. So click on this symbol and find the $sign. So here we don't have $sign. So if you don't find any symbol here, click on other and a character map window will appear here. So this character map mostly contains all the symbols. Here you can see this dollar symbol. Click on this dollar, click on select and copy. Now close it. Now right click here, select paste, and here we have the symbol. You can also perform spell check and there are plenty of other options that you can explore here. To exit this text editor, click on this close text editor or click anywhere outside this text window. Now if you have a large piece of text, for example if you have multiple lines of text, let's say 5 to 10 lines, then you don't need to type all those lines in your AutoCAD. You can directly import them from a notepad. For that, click on multi-line text and create a text box. Select the text style that you want. So let's say that I want to have my style as the standard style for the imported text. And now go to this tools panel in text editor tab. So click on tools and click on import text. Locate the directory where you have saved your text. I've saved text here in this AutoCAD notepad and click on open. So as soon as you'll do this, you'll find that everything that was in that notepad file is imported directly here. You can also adjust this position of text by this ruler. So this ruler is also similar to the ruler which you find in MS Word, and you can also split this complete text into multiple columns. So right now here we have a single column. Click on this columns and click on static column and let's change it to 2, and here we have this text is split into 2 columns. You can not only split it in 2 columns but also you can resize it. So when you increase the size of one column, other will reduce, and you can also resize the distance between these 2 columns in this way. To exit this, click on close text editor. Most of the drawings in AutoCAD are large and complex ones, and they generally contain plenty of elements like dimensions, block, hatch patterns, XREFs, and a lot of other things. So these objects are categorized in different layers, and these layers help in classifying different objects of drawing. Now let's take example of this simple drawing of a bedroom. In this drawing we have some objects like this dimension, these blocks or the objects, this text, and this outer wall. These objects can be classified as different objects and they can be placed on different layers to make them more meaningful. Now let's look at a second drawing. Now here in this drawing we have separated all those objects which we have seen in the previous drawing into different layers. Now this gives a distinct advantage. Let's say that we want our drawing to be without these dimensions. So for that, we can turn off dimension layer, and anything which is on dimension layer will be hidden. So for doing this, click on this drop down. You'll see that I've already created these layers, and here's the dimensions. So in order to turn it off, here I've clicked on this light bulb icon and the layer is turned off. So in this way, we can see this drawing without those dimensions. If you want to turn it on, click on this drop down, click here again, and now it appears again. So in a similar way, we have here plenty of other layers. So 0 is the default layer which will always be present in your drawing no matter what you do. And here's the blocks layer on which all these blocks are placed. You can identify it by its color as well. Def points is a layer which is created all by itself, and it stores all the def points or definition points of a drawing. You have seen this dimension layer and the text which stores this value. Now let's move on to our original drawing. Here in this drawing, we only have this 0 layer and def points which AutoCAD creates automatically. Now here I'll create all those 4 layers as you have seen in this drawing, and I'll place all these objects on their respective layers. For that, click on this layer properties. A layer property manager panel will pop up in which you'll see these 2 default layers. You may or may not find def points layer in your drawing, but this 0 layer will always be present in your drawing. Now to create a new layer, click on this new layer button. A new layer will be created with the default name layer 1. Let's name it. So I'm naming it dimensions, and click outside. Then click again on this new layer and create a new layer blocks, and click outside. Click here again and type text and click outside. So now we have these 3 layers: dimension, block and text. Currently the color of all these layers is default color, which is white. You can change color from here. So here we have this color button. Let's go to dimensions and give it red color. Let's move on to blocks and give it a bluish color. And let's move on to text and give it green color. Now we have assigned different colors to all these layers. Now anything which is placed on text layer will appear green. For blocks it's blue. For dimensions it's red. Let's close this. Select these 2 dimensions and click on this drop down. Move your cursor to dimensions, and here we have it. Now we have placed these 2 dimensions on dimension layer. Similarly, select all these blocks, and from this drop down, select blocks. So now all these objects are placed on blocks layer. Select this text object, click on this drop down and place it on text. So now the drawing is categorized into different layers and it's more user friendly. Layer Properties Manager is like control panel for layers. You can start Layer Properties Manager by clicking this Layer Properties button on Home tab. So when you click here, you'll see this Layer Properties Manager panel will pop up. You can expand this panel and make all the tabs appear. Now here we have some of the options related to layers. By default, you'll see that only 0 layer is present, which is also turned on. That means it is the current layer indicated by this check mark. Def point layer is not present in a blank drawing. It only appears when you create a dimension in a drawing, and currently we have these 2 dimensions here. So that's why this def point layer is already created and you have nothing to do with this layer. Now let's move on to this. Here we have plenty of options. Right click on any of them and you'll see that all these check marks are selected. So these are all the options that you find here in all these columns. Let's say that we want to turn off an option from this. Let's say that we want to turn off this option for on and off. Click on this on, and there we have no longer an option for turning on and off a layer. To make it appear again, right click and select on. Now for most of these options we are not able to see what it's written completely. So for that, right click on any of them and select maximize all columns. So this will maximize all columns and you'll be able to see what these columns actually represent. Now, since we have only a default layer and also a def points, we need to create more layers for this drawing in the background. For that, you've already seen that this new layer button can be used. So click on this new layer and give it a name. Let's say that I want to name it as blocks and press outside. Now we have a layer called blocks here, and all these properties relate to this blocks layer only. Now if you want to delete the layer, you can click on this button, which is delete layer. So let's click on this button by selecting this blocks, select it, click on delete. Now the layer is deleted, so we don't have that layer. You cannot delete layer 0 and def points layer. So these are the two layers that cannot be deleted. And also you cannot delete a layer on which some object is already present. So let's try to delete this object, this layer which is 0. So click on delete and a warning message will pop up. Here you can see that we have 4 types of layers that cannot be deleted. That includes 0 def points, the current layer, layer containing objects, and xref dependent layers. Now let's move on and change some properties of layer. So for that, first I'll create a layer called blocks, click outside, and I'll change its property. So starting with color, I'll change color of blocks layer to red. Now here we have line type, line weight, and transparency also. These 3 values can also be changed, but I'll keep it unchanged. Now let's move on to the drawing. So here we have all these blocks. So select all these blocks, and I would like to uncheck this room 1 and assign it to blocks layer. So from this drop down, click on this blocks, and all these blocks will be assigned to blocks layer. So you'll see that all these objects take the color of layer. Now let's move on and make some other changes. Here we have an option for lock. Let's click on this lock and see what happens. So as soon as you lock it, you'll see that the transparency of object is reduced to 50%, and also this object is completely locked and no change will be allowed. So when you select this object, you'll see that there is no grip point, and even if you try to move it, you won't be able to do so. But still, even after locking this object, you'll be able to snap to its points. For example, here we have the end point for this and the midpoint for this line. So you'll be still able to snap to the points, but you won't be able to make changes to these objects if they are already locked. A locked layer will be faded to 50% of its original transparency. If you want to change the transparency value, then click on this expanded layer panel and change this value. Right now it's set to 50%, so let's change it to 76, and here we have this layer which is more transparent than the previous one. So let's keep this transparency value to 50%, which was the default, and move back to layer properties manager. Now from this property manager, we have 2 more options, on and freeze. For exploring this, I'll create a new layer. So click on this new layer and type dimensions and assign it a color green. Now you must have noticed a peculiar behavior. Initially blocks layer was selected, and when I created a new layer dimension, it inherited all the properties of the initial layer, which was lock and color red. So any new layer will take the properties of the previously assigned layer or the previously selected layer. So let's unlock it. Now here we have an option for turning layer on and off. So first let's assign all these dimensions to dimension layer, and let's turn dimension layer off and see what happens. So here we have a drawing, and let's click on this light bulb icon. So when you do so, you'll see the dimension now disappears from the drawing. Actually, the dimensions are not deleted, but they are temporarily hidden from your drawing when you turn it off. In order to turn it on again, click on this light bulb icon and the dimension will appear again. So in this case, every object which is on dimension layer will appear again. So when you freeze a layer, anything which is present on that layer will become invisible from your view, and AutoCAD will also ignore those objects while regeneration. So once you freeze a layer, that object or the objects on that layer will not be taken into account. So this will increase speed of your drawing, and a lot of memory can be saved by freezing unused layers. So you can always thaw any layer which you again want to use by clicking this button again. Now here we have this external boundary which is on layer 0. So let's go on and change some properties for this external boundary as well. Now here we have line type, line weight and transparency. If you change a line type by clicking here, for that click anywhere and the chair will be placed. Now when you move your cursor to this chair, you'll notice that this is a block, a reference or a reference of the original block which we have created here. And when you select it, you'll notice only a single grip, which is the base point of this block. But here we have some more manipulations to do. So now let's select another option. Click on insert and now go to more options. Now here you'll see your block listed, and you can specify a point with click. When you keep this check, specify on screen insertion point, you can change the scale along X, Y and Z axis, and you can specify the rotation angle as well by clicking this specify on screen radio button. So now click on OK. So let's insert this block again. So here we have this block. Let's select this as the base point. And now when you do this selection, you'll notice that block is not yet inserted, and it will prompt you to enter an angle of rotation. Now you can rotate your block. So I'll select this angle for the block, and here we have it. Now all these blocks are copies of the original reference block which is here. So if you manipulate this block, all the copies will be changed in this drawing. For manipulating any of these blocks, double click on any block. This edit block definition dialog box will open up. Select the block which you want to edit and click on OK. Now this will take you to a different window which is block editor, and you can see a new tab appears here. You'll also see some extra options for manipulating this block and some options for creating dynamic blocks, but we are going to discuss these options later on. Move on to Home tab and change this block. So let's enter a circle in the center of this rectangle. So let's enter a circle. So I'll track this point and I'll track this point, and at the intersection I'll make a circle here. So in this way I've made change to the original block definition. Now click on close block editor and save all the changes. And now when you return back to original drawing, you'll notice that all the blocks have same properties. This object is still not a block because we have retained it as a drawing object. Now let's create another block from this object. So go to create block, give it a name, chair 2 in this case, pick a point. This time I'll select this corner point as the base point, and now select all the objects. Now initially we have selected retain radio button, and that's why the original object on the screen was not converted to a block. Now you can select convert to block to convert this object into a block, or you can select delete to delete the object from screen, but its block definition will be created and you'll find it here in insert option. So let's go and select delete for now and click OK. As soon as you'll do this, you'll notice that the block which was on the screen is now deleted, but when you click on this insert button, you'll notice that chair 2 block has already been created.
Suppose you want to work with a team on a certain project. Now, a team can handle multiple components of a project separately. For example, in case of this floor plan, let's say that a team of designers are working on these blocks or these components like a table, dining table, chair, bed, and all these components, or other designers are drawing the walls and other components. Now, to collaborate their work, you can use XREF and attach all those XREF into a main drawing or a main file. In that way, multiple people can work on a single project and multiple drawings can be attached to a single file, which will be updated in the real time. Now, let me tell you one example of this. Here we have this floor plan, and now I will try to attach one XREF in this drawing. So, a XREF is nothing but a drawing which is saved here. Now, here on my desktop, I have this 73 drawing open. Apart from that, I have got these three drawings. So, dining table, drawing room furniture, and chairs of drawing room. So, these are the three drawings which I am going to attach in the main drawing 73. So let's go to insert, and here on the references panel, click on attach. You'll see that this attach file dialog box will open, and here select the location where your file is present. So I'm selecting desktop, and make sure from file types all files is selected. Now locate the file that you want to attach. Right now I want to attach the dining table. So let's look for that, and here we have this dining table. Click on open, and now you have this attach external references dialog box. Here we have a couple of options. The first one is for scale. Make sure that the scale is set to 1 is to 1 is to 1 for X, Y, and Z axis. Also, make sure that the rotation is set to 0 degrees. You can also click on this radio button to specify rotation on screen. Here the relative path is selected. Apart from that, we have full path and no path options. So when you select full path, a complete path of the drawing which you are attaching will be saved with this drawing. The difference is when you select full path, the directory of drawing, for example, in this case, C users, desktop, and the file name will be stored if you select full path. But when you select relative path, AutoCAD will only remember the directory where the file is present. For example, in this case, AutoCAD will only remember that the file is present in desktop folder. So you can move this complete folder, and AutoCAD will be able to grab that file again when you select relative path. You can also see this when you click on show details. So now when you click on show details, you'll be able to see here the drawing path. But when you change it to full path, you'll see a complete path will be selected. Let's move on to insertion point, and here we have this insertion point selected to specify on screen. Now when this radio button is checked, you'll be asked or prompted to select insertion point on the screen. Also, we have here block unit as inches and a factor of 1. Now let's hide these details, and let's look at this last panel. Here we have two options, attachment and overlay. We'll look at these two options in a moment, but for now I will select attachment and click on OK. So now here we have on our cursor the new external reference or XREF. Now click at a point to attach it. So here we have this attached reference, and as soon as I attached it, you must have noticed a difference. This external reference is faded, and its brightness is half of the brightness of other blocks and drawing objects. So that's a clear indicator that this one is a XREF. You can change fading of this XREF by expanding this references panel and changing the fading from this XREF fading bar. So right now the fading is set to 77, but by default this fading will be set to 50. You can slide this bar to change the fading, or you can manually enter the value in this box also. So by double clicking, enter the value, press tab, and the value of fading will be changed according to your requirement. Now, since this XREF is attached in our drawing, it doesn't mean that this drawing has this drawing component. The component is still present at its original location, which is dining table. And here we only have an image of that. Now, if you delete the original component, this dining table component, you no longer will be able to see this component here. Another advantage of using an XREF is file size will not be increased. Since this component is not present here, it will not affect the file size of this original 73 drawing. Now, finally, we need to get output from our drawings in the form of physical papers. So, in order to get the output, the most efficient and recommended way is using layouts. So, try not to make your plot from model view. So right now you are in model view, but when you hover your cursor here, you'll see that we have here layout 1 and layout 2. So let's move to layout 1 first. Now here we have a viewport and a sample of our drawing here in this viewport. So let's go and delete this viewport. We need to first make sure that this viewport and this layout view is exactly as per our own requirement. So let's try to get our print in A3 sheet size. So for that we need to make some changes to this layout. So let's go to this layout and right click here. Now go to page setup manager. Now this page setup manager will list all the layouts which we have. So let's go to the layout one and click on modify. Now page setup manager will pop up here, and let's start with the first setting, which is printer and plotter. So when you click on this drop down, you'll see a list of all the printers which are installed in your Windows PC. Here I don't have any physical printers, so it's not listed here. But if you have some printers installed here, it will be listed here. I have some virtual printer here, so I will select DWG to PDF.PC3 printer. So let's select it. Now we need to select the paper size. So I'm trying to get my output in ISO A3 paper size. So let's look for ISO A3. So here is ISO A3 297 cross 420. So this will be the paper size in which I'll try to get my output. So let's click on this paper size. Now the plot area. So obviously we would like to get plot of complete layout. So let's select layout from this. And now don't make any changes in plot offset and in plot scale. Let's keep them as they are. Now there are also some changes that you can make here in plot style table. So generally some designing firms have their own plot style tables, and you can use the custom plot style table from this drop down. So let's go to this drop down, click on new, and now you can create your own plot style, or you can import plot style which I have provided to you by your design company. So right now I'm not using any plot style. We'll look into this later on. We have some options here that also we'll talk about. So make sure now that landscape is selected here and click on OK and click on close. So now this paper size is A3. The next step is adding title block. So title block is also provided by the company, or you must have your own title block, and you can import those title blocks as standard blocks. So let's go to insert and here click on insert and go to more options. Now locate the title block. Right now I have a title block on my desktop, so I'll go to browse, I'll go to desktop and select this title block, A3 title block. Click on open and OK. So now this title block appears here on my cursor. Let's go to this corner and click here. So now this title block is inserted completely inside. In this layout view, you're seeing this dotted line. So this dotted line is the plotter margin. Anything which is beyond this line will not be plotted. So make sure that this title block is well within this margin. Now this is the title block which we have made for our drawing, but AutoCAD also provides some title block for you. So when you go to this new template, you'll see a list of template. From this template, when you go to this architectural or manufacturing template, you'll see a preview on the right. So these are all the predefined templates with title blocks for you. So if you want to use these templates and these title blocks, you can use them directly from this template selection box. But if you want to use your own, then you can insert them as a block. So far, we have made many changes to this drawing and its layout, and we have prepared our drawing for final print. But before printing, we need to make small changes to the page setup manager. So let's go to page setup manager by right clicking on layout and selecting page setup manager. Select the layout for which you want to modify the settings and then click on modify. Now, from this page setup manager, we have already seen some of the changes. So here we have this plotter, which we can change from this drop down, and from here we can change the paper size. In plot area, we have selected layout. So this will plot whatever is inside your layout. But we have some other options also. For example, this window. When you select window, this small button will appear, or in some cases, it will directly go to the desktop in this way. Now you can select an area which will be plotted. So let's select this dining hall area. So I'm clicking here and making a rectangular box around this area. Now when you click on preview button, you'll see that only the dining hall will be plotted here and rest of the drawing will be ignored. Let's cross this preview. You have also seen that the dining room is in the lower left corner, but if you want it to appear in the center of the drawing, then click on this center the plot. And now this will ensure that the window will be created in the center or the dining hall will be created in the center. Let's exit this preview and let's now select the layouts which we want to plot actually. Now here we have this plot scale which we are not going to change because we have already made adjustment to the plot scale in the layout itself and the viewports also. Now let's look at this plot style table. So plot style tables are generally some settings which are made in the CTB or STB files, and they allow us to print our drawing with different settings. For example, when you select from this drop-down menu grayscale, then this will plot your drawing in black and white, no matter what the color of any layer or any object is. And if you select a screening of 50%, then it will use only 50% of the original ink amount, and hence the quality of your drawing will also be reduced. Now, here we have another drop down for quality as well. So from this quality drop down, you can select this draft, which is the lowest quality of your drawing, and it will gradually increase. And when you select maximum, this will reach to 200 dots per inch, which will be the maximum quality for your plot. You can also select custom and assign your own quality, which will be measured in dots per inch. So 600 is the maximum amount which you can assign here, and this will represent 600 dots per inch in your drawing. So this will obviously give a great quality of your drawing, but it will use more ink. You can also keep these checkboxes selected and you can directly see what these checkboxes mean. If you want your drawing to be plotted in landscape mode, then select this landscape. Otherwise, you can select this portrait mode as well. And you can check this radio button to ensure that the drawing is plotted upside down in both portrait and landscape mode. So I'll keep it unchecked and I'll select landscape mode. So now we have made all the changes. Let's click on OK. And now let's close it. So we can see that the drawing has moved. So let's select this drawing and move it to the appropriate location. So let's select it and let's move it inside this boundary. Now you're aware that anything which is beyond this boundary will not be plotted. So this is the plotter margin. So now we have made the changes. Let's go and plot this drawing. For plotting this drawing, go to this tab and now hover your cursor over this layout. And now here you will see this plot icon. So click on this plot. Alternatively, you can also press Ctrl plus P to initiate plot command, or from this quick access bar you can click on this plot button as well. Now you don't need to make any change here because we have already made the changes. Directly click on OK. And this will prompt you to select a location for saving your drawing. So let's select desktop, give it a name and click on save. So now since we have selected a virtual plotter, which is a PDF plotter, our drawing will be plotted according to the settings which we have made. And here is the plot output. Now let's go and cancel this. Now let's move on to layout 2 and let's plot this drawing as well. So for plotting this, I'll select this plot button from quick access and now click on this OK button. Let's go to desktop again and click on save. And now here we have another plot of the drawing. Now in both the cases, we have selected plot for each of the layout. You can directly plot all the layouts in a drawing using publish command as well. So let's go to this tab and hover your cursor over any of these two plots or these two layouts. Here you will see this publish button. So let's click on this publish. Now from this drop down, select the format in which you want to get your output. So obviously we want to get our output in PDF, so select PDF. You can also select the plotter which is configured in your page setup manager. So we are not going to select that, we are going to select PDF. So this is a new enhancement in AutoCAD 2016 and you can select the quality of your print. So let's select high quality print, and now here you will see all the drawings which you're going to get in output. So let's now click on publish. This will prompt you to specify your location. So let's select desktop in this case as well. I'm giving it a name of 88.pdf and click on select, and let's select no from this prompt. Now this will generate our plot, and this might take some time as well. So let's close this. And now this bubble is showing that our drawing has been plotted. So let's minimize it and let's look at the desktop. So here we have this 88.pdf drawing. So let's double click, and now here you will see that the model view, layout 1 and layout 2, all the three views are now plotted with a single click. So let's close it now.
In this video, we'll make this drawing mostly with the help of circle tool. So let's start with the line tool first. Click at any point in the drawing area and make a line with length of 30 units and press enter. Now press enter again to exit this tool. Now we have these two endpoints, the left and the right endpoint. And now select the circle tool and we'll make most of the circle on both of these endpoints. So I'll start with the right one. So click on this right endpoint and make a circle with diameter of 182 units. So type D and press enter, then type 182 and press enter again. Now zoom out a little bit to fit this drawing in the visible area and select the circle tool again. Click on this endpoint, the same endpoint which we have already selected, and now click on D to start the diameter option and enter a diameter of 170 unit and press enter again. Now go to the circle tool or press enter key again to repeat the circle, and now click on the same center point and this time make a circle with radius of 70 units and press enter. Now we have these three circles, so let's now concentrate on the second endpoint. So I'll press enter again to repeat the circle tool and click on this endpoint, the left endpoint of the 30 unit length line, and enter a radius of 35 units and press enter. Now press enter again to repeat the circle tool, click on the same endpoint and this time enter a radius of 50 units and press enter. And now we have lots of circles here, and I'll extend this line. So go to the line tool and click on this endpoint and I'll extend this line and join it with this quadrant and now press enter. Now go to the offset tool and enter an offset distance of 9 units, press enter. Now click on this line and click upwards and now press enter. Now go to the circle tool again and click on this endpoint of the line or the center of these two concentric circles, the smaller circles, and make a circle with radius of 60 units and press enter. Now we can trim some of the extra geometries which are not required, and for that I'll select the trim tool. So select trim tool, press enter and carefully remove the part of the geometries which I am removing. So first click on this portion, now zoom into this area and click on this small part of the line. Now zoom into this area and click on these two arcs and clean your drawing in this part as well. So now we have removed most of the unnecessary parts. Let's exit the trim tool and remove some of these lines which are not required. We also don't need both of these circles, so select them and delete them. Now go to the fillet tool from modify panel and enter a radius of 6 units. So click on the radius option, type 6, press enter and select this multiple option. Now click on this arc and on this arc, then click on this arc and this line and this arc and this line, and here we have it, the three fillets. Now press enter to exit the trim tool and go to the rectangle tool from the draw panel. Now click anywhere in the drawing area but not inside the circles and type at on the command line, then enter a length of 6 units, then type comma and enter a width of 18 and press enter. So here we have it, the rectangle. Now select the rectangle, select the move tool, click on this midpoint and carefully move it to this quadrant. Now we'll move it once again. So go to the move tool, select the rectangle, press enter, click on this endpoint, zoom into this area and move it towards left, and when this intersection point becomes visible, click again. So now click on the trim tool, press enter and remove these two geometries. These are not required. Once again, go to the circle tool and click on this endpoint of the line, the left endpoint, and make a circle with radius of 56 units and press enter. Now once again, click on line tool, click on this endpoint and click anywhere close to this point and press enter. Now select the offset tool and enter an offset distance of 25 units and press enter. Now click on this line and click upwards, click on this line again and click downwards. Now press enter. Now select the trim tool, press enter and carefully click on this part of the circle and click on this part as well, and also click on this part, and remove these portions of the lines as well. So remove these geometries carefully as I am removing them. Now press enter to exit this command. Remove this line, it is also not required, and also zoom into this area and remove this extra arc, it is also not required. And here we have it. Most of the drawing is now complete. We only need to make a mirror image of this, but before making the mirror image we can remove this line as well. Select it and erase it. Now select this complete geometry, and while making the selection you'll notice that we accidentally selected this extra line. So you can remove this from selection set by pressing and holding the shift key and then clicking on this again. Now the line has been removed from our selection set, and in order to make the mirror image, click on the mirror tool. Now click on this center point and click on the second center point, or you can click on this midpoint as well if it is visible. So click and press enter. And here we have it, the final drawing as per our requirement. In this video, we'll make a simple wrench in Autocad 2D. So let's start with the line tool, and I'll start with line tool and make a line with length of 70 units. Now let's go to the line tool again and click on this endpoint and make a line in the upward direction with length of 5 units. Repeat the line tool and make it in the left direction with the length of 5 units. Now go to the circle tool and click on this endpoint and make a circle with radius of 10 units. Repeat the circle tool, click on this endpoint and make another circle with 10 unit radius. Now type ML for multi-line and go to this justification option, select 0. Now go to scale and change the scale to 8 and press enter. Now click on this endpoint and on this endpoint of the line and press enter. Now we'll extend this. For that, go to this extend tool, press enter, and now click on this endpoint and then on this endpoint of the multi-line and press enter to escape it. Now go to the trim tool, press enter and trim some of the unnecessary geometries like this. Okay, now we'll remove these geometries. These are also no longer required. And we can also remove this line from the drawing. Okay, now we'll move this line to this midpoint. And we'll also copy this complete geometry from this base point to this endpoint. Now we can reduce the size of this by using scale tool. So select the scale, select the complete geometry, click on this base point and enter a scale factor of 0.9 units and press enter. Now the size is reduced, and now we will make a rotation out of this. So we'll rotate it. So select rotate command, click on this base point and now rotate it with the reference tool. Select reference, click on this point, now click on this point and rotate it approximately to this angle. Okay, now let's go to the offset tool and select the offset distance of 4 units. Press enter and click on this line, click upwards, click on this line and click in downward direction and press enter. Now remove this line, it is no longer required, and we'll also trim a geometry. So select the trim tool, press enter and trim these two circles here. Now let's go to the fillet tool and now go to the radius and enter a radius of 30 unit. Press enter and select the multiple option to repeat the fillet tool. Select this arc and this line, select this line and this arc. Now press enter twice to repeat the fillet tool, go to the radius and this time enter a radius of 8 units. And now click on this arc and this line, press enter. Now click on this line and this arc, and here we have it. Now to add the detail, I'll go to the rectangle tool again and click anywhere in the drawing area. It hardly matters where you click, and make a rectangle with length of 40 units and a width of 4 units. So type at 40, 4, and now go to the fillet tool, select the radius option, enter radius of 2 units, press enter, select the polyline option and click on any of these lines to apply fillet on all the 4 edges. Now I'll move this geometry, so I'll move it to this endpoint, and now I'll move it downwards to a distance of 2 units, just like this. Now if you want to add the detail to this drawing, you can also apply fillet on some of the sharp corners in this wrench. For that, I'll go to the fillet tool, but before that we'll just explode these two multi-lines. So explode the multi-lines. Now go to the fillet tool, select radius and enter a radius of 1 unit. And now select this multiple option to repeat the fillet tool and apply the fillet between this arc, this line, and also repeat it for this side. And here we have it, the final wrench as per our requirement.
Hello and welcome to SourceCAD. In this video, we'll make a simple 2D practice drawing with Autocad. Make sure that you are in drafting and annotation workspace before starting this drawing. So you can switch to drafting and annotation from this drop-down menu. You can also change to drafting and annotation by clicking this gear icon on status toggle and changing it to drafting and annotation. So once you are in drafting and annotation, start with the draw command, and from draw select this circle. So click on this circle from draw panel and click anywhere in the screen to start this command and type a radius of 60 units. So type 60 and press enter. So this will be the first circle. Now press enter to repeat the circle command and click at the same center point, and this time enter a circle with radius 50 units. So type 50 and press enter. Now again go to the circle command by pressing enter, go to the same center, and this time enter a circle with a diameter value of 156 units. So type 156 and press enter. So here we have these 3 concentric circles. Now once you have made these concentric circles, go to this line command and click at the center of this line. Go to this line command and click at the center of the circle. Now move your cursor towards left and make sure that the tracking vector appears, which is not appearing for my case. So for that you need to make sure that this polar tracking is turned on. You can turn it on by clicking on this polar tracking icon or by pressing F10 key. So now our tracking vector is visible. So now track it towards left and click at a point which is close to the intersection point of this internal circle. Now press enter to exit it. You can repeat the process for other side of this line as well. So press enter to repeat the line command, click at the same point and then make a line towards right side. So now here we have these 2 lines. Now select both the lines, type J on command line and press enter. So this will join both these lines into a single unit. Now select offset command from this modify panel. So click on this offset and enter a offset distance of 5 units. So type 5 and press enter. Click at this line and now click upwards. Now click at this line again and this time click downwards. Now repeat the process for the topmost line and click it again upwards, and repeat the process for the bottommost line and click it downwards again. So here we have these 4 lines along with the central line. So let's click on the central line and now delete it. We don't need it now. Now go to this line command again and go to the center point of this circle. Track your cursor towards left, enter a distance of 30 units, press enter, and this time move your cursor upwards and click anywhere which passes both these lines. Now this is the helping line which was required to make this. Now delete this one and go to line command again, click at this endpoint and drag it all the way towards downward direction as well. Now select both these lines using the selection window and type J on command line, press enter, and this will join both these lines into a single unit. Now we need to make a mirror image of this along the center point of this circle. So let's go to this mirror command from modify panel. Now click at this line, press enter, Now click at the center of the circle. So right now the center of the circle is not visible, so click at the side and the center will be visible. Now here we have the center. Now once you select the center, click at any point towards upward or downward direction. So now I'm clicking here, press enter, and a parallel line will be created like this. Now we need to clean this drawing, and after cleaning we'll get the required geometry. So in order to clean it, select trim command. So on modify panel you'll see here trim. Select trim and press enter. Now at first click on all these extra edges. We don't need these edges. Then click at this line and then at this line. Repeat the process for this line and this line. Now click inside and remove these as well. So here we have a completely clean geometry, but when you zoom in this area you'll see that we still have some geometries left here. So these extra geometries need to be trimmed. So first select these two and delete them. Now go to trim command again, press enter, and trim these small geometries. Now we need to trim it from here as well, so click and zoom in, then click at this one and then click at this one to remove it. We cannot trim these lines, so select them and delete them. So select both of them and press delete. So now we have a completely clean geometry. We have one more detail to add here before we finish the central portion of this geometry. For that, go to trim command again, press enter, and trim these two arcs as well. So now here we have the completely clean geometry from the center of this circle. Now let's go to line command again and let's go to the center of this circle, but this time don't click, and track your cursor towards left and keep on tracking till it passes completely this circle. So now here we have this. Make a line which is completely horizontal and which passes through the center. You need not be concerned about the length of this line, just make sure that this line passes from both the sides of this circle. So select this line and make an offset. So for that, select this offset command and enter an offset distance of 90 units. So type 90 and press enter. Click on this line and click upward. So this will make an offset at the distance of 90. Now your offset command is still in continuation, so exit this by pressing escape key, go to offset again, and this time enter a distance of 35 units. So type 35 and press enter. Click on this line and click downwards. So this will again make an offset. We again need to make an offset, but this time it is at the distance of 18 units. So now press escape, press enter, enter 18, press enter again, click on this line and click downwards. So here we have all the three offsets which were required. Now select this helping line, delete it, and then start line command again. This time again click at the center of this circle and drag your line all the way to upward direction so that it passes all the offset lines. Now we again need to make some offsets of this line. For that, click on this offset command and enter an offset distance of 50 units. So type 50 and press enter. Click at this line and click on the right side. Click on this line again and click on left also. So here we have this offset. Press escape and press enter to repeat the offset command. Now this time we need to enter an offset distance of 43 units. So type 43, press enter, select the central line, click on left, select the central line and click on right. Now press escape to exit this. So we have almost made our geometry, and now we only need to add some details. For that we need to trim all the extra portion of these lines. So select trim command again, press enter and trim all these extra line by making this crossing window. Trim all these lines as well and these lines as well using a crossing window. Now zoom this area and click on this line and on this line. We don't need it either. And now this time carefully move at this area and click on this line and then on this line. Similarly repeat the process for this side, for these two lines as well. Now carefully again zoom this area and click at this line and repeat it for this side as well for the same line. Now press escape, and now we need to delete some lines. So select these two lines and similarly select these two lines and delete them. We don't need it. Also delete this central line, that is also not required, and we are left with this geometry.
Now in this geometry again we need to make some trims. So go to trim command, press enter, and first trim this portion, then this, and then this portion. Now we need to trim everything from inside, so click here as well. Now press enter, and one final offset needs to be drawn. For that we need to offset this line towards right side. So go to offset command and enter an offset distance of 10 units and press enter. Now click at this line and click on the right of this geometry, click on this line and click on the left of this geometry. Now go to trim command, press enter, and trim these two lines. Now carefully remove the geometries which I am removing. So click on this one, then this and this arc. Now remove this arc and remove this arc. Also you need to remove this line. Similarly repeat the process for the right side of this geometry. So now click on this line, then click on this arc and then on this arc. So now our geometry is complete and we need to delete all these lines which cannot be trimmed. So select all of these geometries and delete them. So here we have the geometry. We only need to add a hatch pattern of ANSI 31 in the required area. So for that, go to this hatch, select this part of the geometry, and once you select this part, the pattern will be applied at the required area, and make sure that ANSI 31 pattern is selected. Once you have selected the pattern, you may see that the hatch gap is not equal to what you see on the screen. So make sure that you change the scale from here and make it appropriate. So if the lines are very closely spaced, then increase it, and if the lines are far too apart, then decrease that scale value. Once you're done with this, press close hatch creation, and now here we have this complete geometry. So I hope this drawing was clear to you. If you have questions, do let me know in the comment box, and don't forget to subscribe for more such videos. Thanks again for watching.
In this video, I will make this simple 2D drawing, and we'll use mostly polar array tool for making this drawing. So let's start with a base circle, and for that I'll go to the circle tool, click in the drawing area and make a circle with radius of 10 units and press enter. And you may need to zoom in or zoom out depending upon the current scale of your drawing. In this case, I need to zoom in. Now press enter again to repeat the circle tool and go to the center of the existing circle and enter a radius of 7 units, press enter. Now press enter to repeat it once again and go to the same center, and this time enter a radius of 5 units, press enter. Now press enter once again and go to the same center, make a circle with radius of 3 units, and then make another circle with a radius of 2 units. So now we have lots of circles here. We will now add details to the drawing, and for that we need to first make a line. So go to this line tool and click on the center, and now make a line inclined to an angle of 60 degrees. So type this angle sign, then type 60 and press enter, and here we have it, the angle inclined to an angle of 60 degrees. Now click anywhere outside the last circle and make a mirror image of this line. So select this line, go to the mirror tool, click on the center and click vertically upwards and then press enter, and here we have it, the mirror image. Now once again go to the circle tool and select this 2-point circle. Now click at this first intersection point of the second circle from outside, and then on this end point or the intersection point. Now press enter, or you can select this 2-point circle once again and click on this intersection point and this intersection point. Now we need to remove some of the lines and geometries which are not required. So I'll select these 2 lines and I'll simply remove them. Now select the trim tool, press enter, and now trim these lines. These are no longer required, and also remove these 2. Now press enter. Now go to the circle tool and select this center radius circle and click on the quadrant. So if you're not able to see this quadrant, then go to this object snap and select this quadrant option. Now go to the quadrant and make a circle with radius of 1.6 units and press enter. And now we will trim some of the geometries from this circle. So I'll go to this trim tool, press enter and trim this portion. Now we'll make multiple copies of this geometry, and for that I'll go to this polar array tool. Now select it, select the geometry, press enter. Now go to the center, and now in number of items enter 12 and press enter. And make sure this associative option is unchecked and then close the array. Okay, now we need to trim some extra geometry. So I'll go to the trim tool, press enter, and now trim these geometries from this outer circle. Okay, now it's done. So now we'll add other details to the drawing. And for that, once again, go to the line tool and click on the center of this circle and make a line which is inclined to an angle of 30 degrees. So type this angle sign, then type 30 and press enter. And here we have it, the required line. Now make another line, and this time it should be inclined to an angle of 40 degrees. So type angle sign 40 and press enter. And here we have it, now inclined to an angle of 40 degrees. Now click anywhere outside the last circle, and once again we'll trim some of the extra geometries. For that, I'll go to this trim tool, press enter, and now trim these two lines and also these two lines. And now remove these two segments here and select both of these segments, and now we'll make an array. So go to this polar array, select the center, and now in number of items enter 3 and press enter or tab key. And once again make sure this associative option is unchecked and click on this close array. Now go to the trim tool, press enter, and trim these portions of the geometry. Now we need to add the final detail to the drawing, and for that go to the circle tool and go to the same center and make a circle with radius of 6 units, press enter. Now go to the circle tool again and click on this quadrant and make a circle with radius of 1 unit, press enter. And now once again go to the polar array, select the circle, press enter, go to the center point, and now in number of items once again enter 12. And here also make sure associative option is unchecked and then close array. Now once again we need to remove some of the extra circles, so select all of these circles carefully, and these are not required, and remove them. We also don't need this circle, so remove it, and here we have it, the final geometry as per our requirement. In this video I'll make a simple gear. So let's start with the construction lines in this case. So go to the draw panel, expand it, and select this construction line tool. Now click anywhere in the drawing area to start the construction line, and then click on the second point to make the horizontal, and the second point here to make a vertical construction line. Now press enter to exit this command. Now go to the circle tool and click at the intersection point of these two construction lines and make a circle with diameter of 3.333 units. So let's type D, press enter, and then the diameter of 3.333 and press enter. Now we have the circle, but its size is very small, so I'll double click my middle mouse button to fit this circle in the screen, and here we have it. Now let's go to the circle again, click on the same center point, and this time make a circle with radius of 1.5 units. Now press enter again and select the center, type D for diameter, and enter a diameter of 2.571 units and press enter. So here we have these 3 circles. Now let's go to the offset tool and select the offset distance of 0.047 units, press enter, and click on this line, click upwards, click on this line again, and click downwards. Now press escape and press enter to repeat the offset tool and enter an offset distance of 0.130 units and press enter. Now once again click on this central line, click upwards, and click on this line and click downwards. Okay, now we need to make another offset for this construction line. So I will go to the offset tool and select a distance of 0.107 units, press enter, click on this line, click on the left, and then click on the right. Okay, so here we have it. Now we need to remove some extra geometries from our drawing. So I'll go to the trim tool, press enter, and click on this part and then on this part here. Now let's remove this portion also, that's also not required, and let's erase the remaining part. And here we have it, this small arc. So let's now first erase some extra geometries from the drawing. And let's make multiple copies of this. For that, I'll select the array tool. So go to the modify panel and select this polar array. Now click on this arc, press enter, and now click on the center of the circle, which is this point. And in the items, select 18 as number of items. Okay, and also make sure that this associative option is unchecked. So in this case, you can see that this associative option is not checked. Now close the array. Now go to this area of the drawing and select the 3-point arc tool. Now carefully click on this point, the intersection point of this construction line and the circle. Then click on this point and then click on this point. Now repeat the process for 3-point arc and for this side. So click on this point, then this point, and then on this point. Now we again need to clean some extra geometries from the drawing. So firstly, I'll just remove all of these lines. These are not required. And now go to the trim tool, press enter, and click on this circle. And here we have it, the clean geometry. Now go to the fillet tool, select radius, and enter a radius of 0.062 units. Press enter. Now select this multiple option to repeat it for both of these sides. So I'll select this and this portion of the geometry and these two portions. Okay, now we again need to remove some extra geometry. So I'll select these 3 construction lines, remove them, and select all of these objects from here. Remove them as well. Now carefully remove this and this arc and erase them. Now we only have this single gear teeth and we'll make multiple copies of this. For that, I'll select it. Again, I'll go to this polar array, select the center point, and in items, enter 18 and press enter. And here we have it. Once again, make sure this associative option is unchecked and click on close array. And now we have our gear profile almost prepared, but we have these gaps to fill. And in order to fill this gap, we can use this blend curves tool. So select this tool and blend the gap between any of these two geometries. So I'll click on this part and then here on this part. And the gap has been blended with the help of a spline, but we don't want it as a spline, so we need to convert it into a polyline. For that, double click on the spline and from the command line select this convert to polyline option and press enter with the default value of 10 in the precision. And here we have it. Now this geometry is a polyline. Now once again go to this polar array option, select the polyline, press enter. Now go to the center here and in number of items enter 18 and press enter. And now you can clearly see that all the gaps are now filled. Once again, associative option should be unchecked and close the array. And now we have our gear almost prepared. Now we only need to make the internal profiles, and for that I'll select the circle tool. So select the circle tool, click on this center and make a circle with a diameter of 0.5 units. Now press enter again, click on the same center point and make a circle with radius of 0.5 units. Press enter, click on the same center point and make a circle with radius of 1 unit and press enter. Now we need to make a keyway, and for that I'll select this rectangle tool and click anywhere in the drawing area. You can even click outside, so I'll click here. Now type at on the command line and enter 0.12 as length and 0.06 as width and press enter. And here we have it, the keyway. Now select it, select the move tool, click on this midpoint and move it on this quadrant. And now zoom into this area, select the rectangle, select the move tool, click on this endpoint and move it downwards carefully up to the intersection point. Now we can remove these two geometries here by using trim tool. So select it and remove them. And here we have it, the keyway. Now we can remove this circle as well. It's no longer required. And here we have it, the 2D profile of our gear. In this video, we'll make this 2D drawing. So let's start with a simple line tool. So I'll go to this line command and click anywhere in the drawing area and make a straight line with length of 230 units and press enter. Now press enter again to exit this command And now go to the circle tool and click on this endpoint of the line and make a circle with radius of 11 units and press enter. Press enter again and go to the same center point and make another circle with radius of 9 units and press enter. Now let's zoom into this area once again and make another circle with radius of 4 units here. So let's type 4 and press enter. Now here we have it, these 3 circles. Now let's go to the line tool again and click on this midpoint and make a line in the downward direction with a length of 7 units and press enter again to exit this command. Now we'll copy this complete concentric circle geometry and we'll copy it from this center point and we'll copy it to this point and to this point. Now let's go to the circle tool again and click on this point, the center point of these concentric circles, and make another circle with radius of 17 units and press enter. Now let's go to this circle flyout, expand it and select this tangent radius option. Now click on this circle and then on this circle and enter a radius of 200 units and press enter. Now we need to trim this extra portion here, so for that I'll select this trim tool, press enter and click here to remove it. Now we can make a mirror image of this. For that, select it. Now go to the mirror tool, click on the center point of this circle and then click on this midpoint and press enter. Now we need to offset this one to a distance of 22 units. So for that I'll select the offset tool and enter a distance of 22 units, press enter, select this geometry and click upwards. Repeat the process for this arc as well. And now we need to add fillets. For that, here we have this fillet, select it and enter a radius of 5 units. So type R, enter 5, enter and select this multiple option, click on this arc and click on this circle. Repeat it for this arc and this circle as well. Now press enter to exit this command. And now we can remove all the unnecessary geometries which are no longer required. So we don't need this line and we also don't need this vertical line. Now let's go to the line tool once again and track this point, this quadrant, and click anywhere close to this point and make a straight line like this. Now go to the offset tool and enter 27 as the offset distance and click on this line and make an offset here. Now go to the offset tool again and this time enter a distance of 50 units, press enter. Now click on this line and click on the right side and press enter to exit this offset tool. Now go to the trim command, press enter and trim all the extra edges here. We don't need them here. And also remove this line, it's also no longer required. And go to this offset tool once again and enter an offset distance of 11 units, press enter and make another offset of this arc here. Now we need to rotate these two lines with respect to this intersection point. For that I'll select this rotate command and now select this line and press enter. Now click at this intersection point and enter an angle value of -15 unit and press enter. Now go to the rotate command again, click on this line, press enter, click on this intersection point and enter an angle value of 15 units and press enter. Now we can remove this arc, it's not required anymore, and we need to make more offsets here. For that I'll go to this offset tool and enter offset distance of 3 unit, press enter, click on this arc and click upwards. Now click on this arc and click downwards. And now we need to make some fillets. So go to the fillet tool, click on this radius option and enter a radius of 1 unit, press enter. Now select this multiple option and now click on this line, then this arc, this line, arc, and repeat the process for all of these 4 edges. And here we have it. Now we need to make a mirror image of this on this side. So I'll select this complete geometry, go to the mirror tool, click on this center point and directly click upwards and press enter. Now we need to remove some extra portions here for this circle. So I'll go to this trim tool, press enter. Now click on this part and this part. And here we have it, the final 2D geometry as per our requirement.